hydrometeorological risks. So it's going to be a better and a more inspiring lineup of eminent speakers in these 3 days. Very timely initiative, as I mentioned earlier. Recently, the Joshimath incident in Uttarakhand, which not only took a lot of human lives, but has caused major damage to the ever-existing infrastructure, power infrastructure and road infrastructure in that area, and which rings a bell again that how well are we prepared, and what we need to do to make our infrastructure more resilient going forward. So on that note, I know Dr. Muzaffar Ahmed is hard pressed for time and he has another engagement. So I would now request if Dr. Ghosh, would you like to add something, or can we invite Dr. Ahmed for his remarks?
Sorry. Only.
So I would like to,
I'm thankful, Dr. Muzaffar Ahmed, that you always with us. Your presence and your encouraging and also action and inspiration is always there with us. So I would say that the kind of initiation that the Picky team, it is not only Ruab only, he is in the front page, but all teamwork is more important in the country. And we always remember the Chak De India, no? The game, that hockey, and so that is the kind of things that on a very challenging issue that we have been facing. In that way, that we have got so much of cooperation from whoever we have called, especially even a day before, or even few hours before, they all agreed, whoever we have approached. So that is one inspiration. And also a lot of site visits are being planned, which I got an update from Dr. Surya Prakash today morning. In fact, he is on a out of station, but he says that he will be giving on just speech only. He is now on a tour. So he will not be able to present it, but he will share his experience since 1991 onward, Uttarkashi earthquake onward to till date, that he will speak only over the phone in the last speaker. And so today, I think you have already mentioned, we have 4 presentations, and after that we sum up the session. And we see that this Ajanta is here. Oh, welcome, Ajanta. So these are all teams that we are making. In fact, that all I hope that they are below 40. This is what I was mentioning. That above 40 or 45, no, they have reached certain height. But we want to take this young team. Dr. Ajanta Sachan, he was with IIRS. And so, but he has joined in the academics now in IIT Roorkee. Of course, formal parichay aapka honge. At the same time, I would say that Dr. Muzaffar Ahmed, please, you please you of your just.
Good afternoon. Thank you, Rubab. Thank you, Professor Chandan Ghosh, for giving me the opportunity to say a few words on this training program. I tell you, the topic of the program, that is the resilient infrastructure for hilly areas, has been, it's a very important topic on the subject, knowing what happened in Rishikesh, what has happened in the past in many areas. As we know, all our hilly areas, whether Northeast, Himachal, J&K, Uttarakhand, they're all vulnerable to not only to earthquake, but some areas vulnerable to landslides and avalanches, snow avalanches. Although the country has done a lot and we have progressed in the early warning system, especially SASE has been doing an excellent job in giving the timely early warning for the areas. I remember even in the high altitude areas of J&K, we used to lose large number of people, especially who would come from the far-flung areas, snowbound areas to valley, and there would be, because they had no means to to listen to radio, but now regular timely early warning given by SASE makes all the stakeholders and the administrators to act timely, and they ensure that people don't die due to snow avalanches, especially in our forward areas where our Jawans are located, and especially in high-risk areas where we have every chance of avalanches. We have seen even in the 2011 when Ladakh in Leh cloudburst, the devastating effect was there, and followed by in some other areas with landslides. And although the response has been there good, but what we have seen that the infrastructure, especially at the community level in these areas, has to be resilient, and what is required is what we have been community-based disaster risk reduction, and ensuring that whatever they invest in there, whether in housing or other infrastructure, they make these infrastructures resilient for various disasters. And also the structures, infrastructure which is coming from the government also is made in a way that we don't lose those infrastructures due to either snow avalanche or landslides or even an earthquake, especially the critical infrastructure, hospitals, schools, which have to be taken care. And I must tell you, this 3 days training program, eminent speakers have given presentation, and I must compliment them. And I must compliment Rubab, his team, Akhil, Varun, Sanjeev, Mainek, and Professor Chandan Ghosh, and the other staff, and in fact, the ED of NIDM, General Bindal, and our chairman of the board, General Bharadwaj, for giving the patronage for this board and for having these training programs. And large number of training programs have been conducted jointly. And conducting and organizing training program needs a lot of efforts, for which I compliment you, both Rubab and Professor Chandan Ghosh. And I'm sure with these trainings, we are going to fulfill our goals as per our Sunday framework, making our infrastructure in our areas of vulnerable areas resilient, and ultimate goal is saving people from mishaps, from emergencies, so that we don't lose precious lives. I thank you all, and I must compliment the participants also who have been here with us for 3 days and listening to the various speakers, eminent speakers, I must say, those who have expertise in these fields and have contributed a lot in their domain. And with these words, I wish you all the best. Thank you very much.
Thank you so much, Dr. Ahmed, for your very encouraging remarks. You've always been very, motivating and inspiring, to the entire platform of CIDM. We are very blessed to have General Bharadwaj, yourself, Mr. Mansingh, and Mr. Rao from the PMO, as 4 very important pillars of CIDM board. And I think it was your leadership that led us to this partnership with NIDM. And today we are almost, although we've been working with NIDM for the past decade, but under this formal arrangement, I think we've really touched new heights. And we reached out to over 7,000, industry representatives, people from the civil society, from various professionals, from government officials, all of them in this past 10 to 11 months. We've been very in that way. And in that moment, I would like to share a few, although Dr. Ahmed needs no introduction, but I would just like to still tell you and share with you, Dr. Ahmed is former member of National Disaster Management Authority, Government of India, and had was accorded with the status of Minister of State at NDMA. Highly experienced, he has looked after industrial disaster management, mitigation, earthquake, and other important subjects at national level. Dr. Ahmed had been instrumental in formulation of more than 8 national guidelines at NDMA, recipient of Dr. B.C. Roy, a very prestigious award, national award, which was bestowed on him by the Honorable President of India. Dr. Ahmed has written more than 6 books on disaster management. He has represented India in many national and international forums, has been the face of the valley. I think from Jammu and Kashmir perspective, he led the health division department there for a number of years, and through various from earthquakes to floods, he's been a pillar of great support to Jammu Kashmir in helping them, get out of those difficult times. Thank you so much, Dr. Ahmed, for your support and for your very inspirational work throughout your career. And thank you again. Thank you. So, Dr. Ghosh, with your, I think, permission, shall we go on with the first speaker, Dr. Ajanta Goswami? He's waiting, for us to start the proceedings for the day. Ladies and gentlemen, Dr. I would just take a moment. Thank you so much, Dr. Goswami, for joining us today. I would, before I request you to make your presentation on this third day, the first presentation, I would like to share a little bit of view with the audience, which is almost 150, and they're coming in, joining in. We could excuse them for a Saturday, I think, but they're still showing equal interest to as they showed in previous days. Dr. Ajanta Goswami is an assistant professor at IIT Roorkee. His areas of interests include application of remote sensing for geological and geohazard studies, cyrospheric study using earth observation and ground-based study, landslides, urban heat characterization using earth observation and ground-based study. He was a team member of the deepest offshore gas discovery in India under highest pressure temperature. Has been his professional background. He's with IIT Roorkee for now since 2015. Has been in the Indian Institute for Remote Sensing, IIRS, ISRO Department of Space, as scientist for 5 years. Then he was, before that, was also a faculty at the Center for Space Science and Technology Education in Asia and Pacific for over 5 years, and been a part of CSIR-led initiatives also. So without taking any longer, I would now request Dr. Ajanta Goswami to make his presentation. Over to you.
Thank you so much. My screen is visible. I guess my screen is visible. Okay.
Yes.
Okay. Thanks for a nice introduction. Thank you, Chandan sir, for the initiative. And it's almost 10 years since I'm working with Chandan Ghosh sir. And we have been listening to very nice presentations since last 2 days. Very nice deliberations on whatever happened in Chamoli and what could be done or what we can do in future. So my lecture today, or my presentation today, is mainly focused on few previous incidences or events that took place in Uttarakhand, which are related to glaciers or glacial-like outburst flood, both glaciers and glacial outburst flood, and what were the preparedness and what is the way forward. So it is just a retrospection, because even this Chamoli incidents happened on 7th February, and whatever damage was supposed to be done is already, it's over. So that's what is retrospection and previous events that I'll be discussing in my lecture. So I'll be taking 3 different case examples. One is from the Chamoli incidents, second is from the Kidana incidents, and third is from the Gonatal incidents. I think many of you have heard about the Gonatal incidents of early 19th century. Okay, to start with, whatever I'll be presenting here, I acknowledge Professor Anil Kulkarni from IISc Bangalore, my students Asim Sattar and Rohit Kumar from IIT Roorkee. And again, Vijay Ketan Mohanta also. And few of my work is from my previous collaboration with Dr. P.K. Champatire from ISRO and Dr. Praveen Thakur. So all these works I'm putting together, which we have already published. So this map, perhaps many of you have seen in many of the presentations. So this is all about the Alaknanda Valley, where the extreme left part, the first catchment is Saraswati catchment. The second catchment is Dholiganga catchment, and the lower part, the eastern catchment, is the Rishiganga catchment. And whatever event took place, the disaster which took place, it was in this particular Rishiganga catchment only. So what happened that day? Many of you have listened to the deliberations yesterday, where L.K. Sinha sir has very nicely presented that what exactly happened in that particular area with some ground photographs as well as ground evidence also. So this was what we found initially from Planet Lab data, that on 7th of February at around 10:33 a.m., if you see this particular figure, this particular image, you could see that there is a patch of plume, dust plume. This could be dust or this could be moisture, which is quite evident in this particular basin, in this particular valley. Whereas this particular plume is not visible anywhere in other part of the valley. It is present only in this particular valley. So this indicates that whatever happened, it might have happened here only, along this particular narrow valley only. So if we look at the same image at 10:58 a.m., means almost roughly 20 minutes later, you could see that the plume now, it's half of the plume is gone and only half is left. So this indicates that whatever happened might have happened on 7 February 2021 at around 10 to 10:30 a.m. That was the probable time, because it took almost 20 minutes for the dust plume or the moisture to settle down. So that indicates that it might have taken place at around 10 to 10:33 a.m. But yeah, still we need to confirm it from field verification as well as other data. Even if we look at the precipitation data, so this is the AWS data of Topo 1 area, which is a point data, and precipitation is in millimeters. So we could see that the precipitation was there on 3rd February, 4th February, as well as 5th February. It was high, but it was not that high, around 18 millimeters. So 18 millimeters is not very alarming. This was a zone from where that movement took place, or the avalanche took place, if at all it is classified as avalanche, or if it is classified both as a landslide and avalanche, that it took place on that particular, from this particular area. And these are few of the images, previous images. These images of 21 January 2021, where you could see that there was ice cover, snow cover. On 1 February 2021, again that area was snow covered. If we look at 3, yes, there was cloud as well as snow cover. 4th, there was huge snow cover. 5th, there was again huge snow cover. 6th, also there was snow cover, but we don't know about the thickness of the snow cover, how much snow cover was there. On 7th, you could see that there is a portion in the valley which is almost barren. It means the incident took place and there is a gap in this particular area, which shows that something actually fall down from this particular place. So the avalanche took place from this particular place, and from 8 onward, you could see that there is a huge gap in this particular area, or the snow cover is gone. So this is the close-up image. This is for 6th, this is for 7th, and this is for 8th. And all our previous speakers have already confirmed that what is the dimension of that particular chunk which fall down, whether it was snow or it was ice or it was mixture of snow, ice, and debris. All these things have already been deliberated. So I'm not going to details about all these things. And this is again image that I got from Twitter, actually, from different authors, where it is the pictures are shown that what is the dimension of that particular chunk. And from DEM, the dimension of the chunk was also measured. So all these things we have already seen. I am just repeating the same information which was presented previously. So now few questions are still left. So one of the important question is that if at all this was because of avalanche, then what was the source of water? Because if we assume that avalanche was because of snow or ice and mixture of snow, ice, and debris, then whether it melted so suddenly that's such a huge amount of water was released. So that's still a question. People are still working on that particular aspect. We are also working on that particular aspect from different point of view, and we are trying to find out that what was the source of water. There are many hypotheses actually, like from IAC, the hypothesis, initial hypothesis which came was there are certain supraglacial lakes located along that particular glacier, which must have been punctured because of the avalanche, and that might have contributed the amount of water, huge amount of water. Although confirmation is still waited, and a few of the famous geomorphologists also, they have, like Dan Sugar, they have confirmed, they have told that we should do geophysical survey, resistive activity survey or GPR survey to find out that whether there were some glacial lakes, supraglacial lakes, which punctured because of that particular avalanche. So this is one of the theory that supraglacial lakes were there, which were punctured, and that released the water. So even I told that same theory. Second theory which is coming up is partial damming. So it was told that there was a partial damming in that particular area, and because of the damming, once that ice wall or that snow wall or the debris wall was broken, the water was released, and which caused that huge flood. Now, again, we will have to confirm that if there was partial damming in that particular river valley, so discharge might have been reduced for a certain amount of time. At the same time, if we know the discharge of that particular tributary, then we can find out that if X amount of time it was dammed, that how much water it could have hold, and whether that much of water was enough to cause this this huge downflow. So that is again yet to be confirmed. And third theory is about the melting of snow and ice, as well as because of the frictional heat or because of the other heat. So again, the studies are going on and it is not yet confirmed. So we are still waiting to discuss that particular, the final cause of that particular disaster. So this is what we have seen in Chamoli, and we have heard a lot about the incidents that took place in Chamoli. Now I want to take you back to the incident which took place in Kidana, because there are some 2-3 incidences which can be correlated, although those 2-3 incidences are completely different. Like this incident took place in winter season, but the Kidana incidents, it took place in summer season when there was monsoon, there was huge rainfall, and it was multiple hazard. It was not one hazard, but it was a multiple hazard. Then there was another hazard which took place in early 19th century, which is called as the Gonatal incidents, and that took place because of landslide. It was a complete landslide dammed lake which breached and caused all the damage. So I'll be discussing all these 3 different events together, and we'll try to find out that what was the preparedness and what people did at that time and what we need to do now. So let's go to the Kidana incidents first. Many of you might have seen this particular picture. This is Rambada, which was once upon a time it was existing, and it was midway between Kedarnath as well as the downstream. People, when they used to start trekking, many of the people, they used to stay here for the night, or they used to take rest. This was a midpoint. When we did further analysis, means after the disaster in 2013, when we go for the recce, we found that that whole area was now barren, and there was no trace of any township or any building or any people living there. Okay, that whole area was actually washed away. And this was the Kedarnath temple. You could see that the temple was quite high, around some 5-6 feet, or even maybe around 7 feet high from the ground. But after the disaster, it was completely covered by debris. So it was not half buried, but it was buried till its floor. So Kidana is located at a height of 3,583 meters, and it is around 223 kilometers from Rishikesh, and it is at the shore of Mandakini River, which is a tributary of Ganga. So if you look at the upper part of the image, this particular image is taken from Google Earth, which shows that particular valley, how that valley looks like, and after disaster, how it looks like. If you look at this particular image towards the left-hand side at the bottom, so this image, at that time I was working with IRS, and this image was prepared from the Cartoset DEM as well as the list4 data which was available for that particular area, and using those 2 data sets, this particular image was prepared. And these were the first initial images which were provided to Air Force as well as to NDRF teams and other people who were involved in field rescue operations. So at that time, we were working day and night, and we were providing all this data to both Air Force as well as Army and NDRF teams. So the whole story revolves around this particular lake, which is called as Gandhi Sagar Lake. And this is from a file photograph. I took it from Google. And the lake area before the breach was around 3.4 to 3.6 hectares, with a length of around 320 meters and width of around 160 meters. So it was not a very big lake. It was quite a decent sized lake, small sized lake. And perhaps very less people might have thought that it will ever breach and it will cause such type of catastrophe. So this figure we took, this particular picture we took after the disaster, and now you could just compare the previous one and the next one, that what was the total scenario and how it looks like. And these are we people, me and my friend, who went for the recce, and we did all the field survey in that particular area. And if you look at the depth of the particular lake, the depth ranges from 20 meters to around 40 meters. Somewhere it is around 20 meters, somewhere it is around 40 meters, somewhere even less. Average depth is around 20 meters for that particular lake. And these are few of the, rescue operations and some crashed helicopters also. This was one of the bridge which was completely damaged, which was connecting Kidana temple with the lower part. These are few of the horrible things that could be seen in the field. There were many skulls and skeletons lying all around. Some 5 photographs of Kidana temple. One is from 1882. The source is GSI. Okay, so what happened in Kidana at that time? IMD confirmed that Dehradun station, from the Dehradun station, that there was an rainfall of around 595 millimeter in 48 hours, and it was quite huge. And why this rainfall took place, why this huge rainfall took place at that time? It was told that this extreme event was a rare combination of 2 active systems like westerlies as well as southwest monsoons, which is already confirmed, and many papers are already published. The Chorabari Tal, which is located around 2 kilometers upstream of Kedarnath town, if you look, if anyone has gone to that particular area, that particular tal or that particular lake, it breached, and the length of which was around 62 to around 64 meters, and it was a V-shaped breaching. Okay, and we have confirmed it from field. Actually, we went to field and we have done all the measurements. So it was around 62 to 64 meters of breaching, and it was a V-shaped breaching. And it indicates that there was overtopping, and then it was followed by deep incision in that particular lake. And the water level in the lake had risen approximately 20 meters. So that was what the rise in water level was there in that particular lake. And the lake area before the breach was around 3.4 to 3.6 hectares. And the length was around 320 meters and width was around 160 meters. And the total volume of water, which was approximated, or which was estimated from the DEM of the post-event, so we could find that there was something around 71 million meter cube of water was there in that particular lake. So the DGPS survey location, as you can see from this particular picture. So height difference of 20 to 40 meter, and on an average it was around 20 meter for this particular lake. And total volume of water is estimated to be 0.71 to 0.72 million meter cube. And average discharge estimated to be around 1,192 meter cube per second, considering the fact that the lake emptied in 5 to 10 minutes. So we have taken some ground interviews also of the local people, the priest and whoever were available in that particular area just after the incidents. And they have confirmed that in 5 to 10 minutes, the whole lake was emptied and that particular flash flood came and it went away. So from that, when we calculated the discharge, so it was found that the average discharge was around 1,192 meter cube per second. And the peak discharge was estimated as 5,376 meter cube per second. And it was, the peak discharge was estimated using the dam break formula, which is given by Hunger et al. And we have referred from Rickenman 1999. And this is the formula which we have used. You can go through our paper also to find out that what exactly equations we have used. This is the breaching which took place. Okay, and you could see one of our students who was taking the measurement. You could see the dimension actually, that how big the breaching was. And the breaching length was around 62 to 64 meter, and it was a V-shaped. And it indicated overtopping, and after overtopping, it was followed by deep incision. And if we consider the valley width at Kedarnath town around 320 meter, so when we estimated the valley width along the Kedarnath town, it was around 320 meter, okay, along the 2 banks. And average water column height is estimated to be around 3.7 meter for a duration of 10 minutes. So this average column height, all these things were done from field only. We have taken all this measurement from field only. So considering the fact the lake was emptied in 5 to 10 minutes, again, I'm repeating, the average discharge was 1,192 meter cube per second. Peak discharge was around 5,376 meter cube per second using the dam break formula by Hunger et al. And the lake, around the Kidana town, it was 320 meters average water column height is estimated to be around 3.7 meter, and it was for a duration of around 10 minutes. And similar flood level water of 3.2 to 3.8 meter was also observed by eyewitness and survivors in Kidana town area, as they told us. It was also estimated that water with debris would have reached within 5 to 7 minutes with a minimum velocity of 4 to 5 meters per second, thereby giving no chance to people, because people, they said that they have heard a big sound, actually banging sound, when the breaching took place. And within 5 to 7 minutes, actually the water and the debris, it reached Kidana temple. So there was very, very less time for people to even evacuate. There was no chance for people to escape, and that's why all the casualties took place. And the minimum velocity was around 4 to 5 meters per second. Why? It is because it was not only pure water, but it was muck, which was consisting of both silt, sands, as well as big boulders and cobbles and pebbles. All these things were mixed together. Yeah. So this was the whole story of Kedarnath disaster. Now let's go to the Gohnatal disaster, which took place in 1894, although we don't call it as a disaster. So what happened in Gohnatal in 1894? This particular tal, it is the devastation of 2013 and as well as 2021. It means the one which took place in Chamoli area, and the one which took place in 2013 in Kedarnath area. Both these incidences could be compared with the incidents which took place in Gohnatal in 1894. So what happened in Gohnatal? So this was a spectacular lake which was created by a huge rockfall. So there was a huge rockfall in that particular area along the right bank of Birahi Ganga river, and which is a tributary of Alaknanda river, which blocked the river in September 1893. It means in September 1893, there was a huge landslide, a rockfall actually, and this whole rockfall, what it did, it actually blocked the path of Birahi Ganga river. And because of blocking the path of the Birahi Ganga river, there was a huge reservoir which was created, okay, and which is called as the Gohnatal. And the breaching took place for the first time in 25th August 1894, which caused widespread inundation in the downstream. So in September 1893, it was blocked. In August 1894, the first breaching took place and it inundated the downstream areas. So how damming took place? So it is told that on 6 September 1893, 2 landslides took place on the right bank of the Birahi Ganga. And one side of a steep hill measuring 1,300 meters above the level of the stream crashed down into the valley, and it brought down large blocks of limestone that formed a dam of more than 3 kilometers wide at the base and 600 meters at the top. You might have actually attended yesterday's few of the lectures where the dimension of the new lake which is forming there is also told. And just compare the dimension of this particular lake. It was 3 kilometers wide at the base and 600 meters at the top. And height of the lake was 270 meters. So you can just imagine the dimension. And total rock volume was estimated to be around 150 to 200 million meter cube. This is how it looks like after the lake breaching took place. Now it is completely empty, and you can see that whole valley where the lake was previously. So these are some file photographs of Gohnatal in 1894 and 2006. Okay, just you can compare from these 2 file photographs. So in December 1893, the area of the lake was around 2.5 square kilometer, and its depth was around 145 meter. Just imagine 145 meter means how huge it would be. By July 1894, the lake had become nearly 6 kilometers long and 800 meters broad, and the level of water has risen nearly 55 meters to total of 200 meters. So by July 1894, the height of water was around 200 meters, and it was around 6 kilometers long and 800 meters broad. So that big it was. The first breaching which was reported, it took place at 11:30 p.m. on 25 August 1894. And at that time, the lake volume was around 417 million meter cube. And before the first breach on 25 August 1894, it means before the breaching took place, the lake volume was estimated as 470 million meter cube. And the breaching took place exactly at 11:30 p.m. on 25 August 1894. During the breach, 283 million meter cube of water was released, and still 187 million meter cube was left. It means the lake was not completely emptied. It was still there, but from 470 million meter cube, it came down to 187 million meter cube because 283 million meter cube of water was released, which was part, and the lake was filled up with sediments in subsequent 78 years. So for next 78 years, there was nothing which was happening in that particular area, and slowly sedimentation took place, although there was some amount of water still there. Around 187 million meter cube of water was still there. During August 1894, the drawdown from the lake was 19 meter, which happened over a period of 4.5 hours, equivalent to average discharge of 17,479 meter cube per second. So just imagine the Kedarnath incidents, where I told you what was the peak discharge at that time. It was around 5,000 meter cube per second. And here the average discharge was, and average was around 1,200 meter cube per second. Here the average discharge was 17,479 meter cube per second. So you can just imagine the dimension of that particular water release, that how big it was, and how compared to the Kedarnath disaster, how big it was at that time. So how the government planned in 1894. So how British at the time, India was part of British administration. So what they did, the anticipated flood level was marked by masonry pillars every half a mile interval along the Birahi and Alaknanda Valley at a height of 60 meters above the ordinary flood level, above which it was considered as safe. So first thing that they did was, along the whole valley, there is always a flood level. Okay, we all know that along all the valley, government agencies, they used to mark the flood level. So 60 meters above the normal flood level, that was considered as the safest place. Means if normal your flood level is this much, so 60 meters from here, so that was considered as the average flood, means a safe area above which people can stay. 8 suspension bridges were between Chamoli and Haridwar were dismantled in order to protect them from being washed away by the anticipated flood. So 8 suspension bridge at that time, they were dismantled so that nothing happens to those bridges and they can be immediately restored later on. Along the pilgrim road to Badrinath shrine, diversions were constructed to minimize the impact of disaster. Because people already know that this is going to happen, so there was lots of preparedness. A British soldier, his name is Lieutenant Cruikshank, and he was positioned to keep watch on the lake with a telegraph cable that would allow him to sound an alarm. Okay, so okay, and the first sign of breach was heralded by the sound of bell, and the warning was communicated by telegraphic messages, bonfires, rockets, beating of drums. So all these things were done. The most important part of this particular preparedness was, for the first time in Garhwal, Himalaya, a telegraphic connection was established and used for emergency communication. So just imagine in 1894, they used the best technology which was available for the preparedness. What they did, that they installed a telegraphic connection for the emergency communication. So which is itself, it indicates that how much amount of preparedness we need to do. We should use the best of the best technology which is available to us. And how that flood impacted, the flood water hit Srinagar, which is 116 kilometers away, in 4 hours with a speed of 8 meters per second. And Srinagar, with a population of 2,000 in those days, was destroyed completely, but there were no casualty. So in Srinagar, the Palace of the King, police station and Dak Bungalow were destroyed completely. Flood level in case of Chamoli was 49 meters. At Rudraprayag, it was 43 meters. At Karnprayag, it was 40 meters. Nanprayag, it was 34 meters. Srinagar, it was 13 meters. And Haridwar, it was 3 meters. And total damage which was caused at that time, it is valued around rupees 95,000. But no lives were lost except those 5 people who insisted on remaining just below the dam. So that is the success of that particular preparedness of the government agencies at that time, that there were no casualties. Although 5 people died, but they died of their own fault because they said that they are not going to evacuate their place, the home that they were staying. So only those 5 people died. Apart from that, there were no casualties. Although the damage to infrastructure was huge and around 95,000 rupees at that time. So that was the total damage. So first breach took place on 25 August 1894. Second breach of Gonatal occurred in 1924. The third major breach occurred in 1970, and which coincided with the Great Alaknanda flood, and it is also called as the Belakuchi tragedy of 1970. And due to the heavy and continuous precipitation, prior to 20 July 1970, the Gona Lake, again, the water level was quite high. And for the third and final time, the lake was emptied. And after that, the Gonatal incident is now over. So these are 3 incidences that we have seen till now, the major incidences that we have seen till now in Uttarakhand. So what exactly national and international policies says about this thing? I hope I have some time to present more. So I have a few more cases to show actually. So several national and international policies like Bureau for Crisis Prevention and Recovery and United Nations Development Program, they have recommended and have targeted glacial lake monitoring and GLOF hazard assessment to be part of its action plan, which is UNDP 2012 plan. So these are few of the plans which I'm not going to discuss any further. So need of the hour is, now what exactly, after seeing all these 3 events, what is the need of the hour? The need of the hours are like, we should do a GIS-based multi-criteria analysis to identify the potential dangerous glacial lake. The first important thing is we need to identify all the potential dangerous glacial lake. Although now we need to add one more thing, that we need to spot those avalanche prone zones also. Detailed investigation of the lakes using field-based mapping technique is also very important. And third is modeling different failure mechanisms like piping, overtopping using 1D and 2D hydrodynamic modeling is also equally important. So I'll show some more case studies that we have done. Okay. So this is for Uttarakhand, and here one example I'm going to show for the Satopan Tal, which is in Alaknanda Basin, and one is in Dhauliganga Tal that I'll be showing here. Okay, so first study that we did was we tried to find out the hotspot zones, that which are the hotspots where exactly actually the forcings are changing. Forcings in terms of rainfall, in terms of precipitation, in terms of temperature, in terms of solar insulations. Okay, how these forcings are changing. So we have done here. I'm showing only two examples. One is for rainfall and another is for temperature, air temperature, sorry, surface temperature. That how these two things are actually varying in this area, because our priority was to find out those zones, those spots where the changes are taking place. Although we are talking about the global climate change, that okay, climate is changing all over the world, but the change in climate is not uniform. There are certain pockets where the impact is more. So our main emphasis was to find out that which are the pockets, which are the hotspots where the changes are taking place. You can go through our paper to find out what exactly we have seen in this particular case. Second thing was we tried to map all the glacial lakes of the of Uttarakhand area. And we have mapped from 1968 onwards. We have used the Corona data or hexagon data from 1968, which are black and white images. Till 2016, we have done the mapping. So in 1968, we could identify 60 glacial lakes, and this mapping is done at 1:50,000 scale. So scale, like if you are using any satellite image, you can easily find out that your pixel size multiplied by 2000 tells about the scale. So if you are using, suppose Landsat data of 30-meter resolution, okay? So from 30-meter multiplied by 2000, it means 60,000. So your scale of mapping will be 1:60,000. So that's how you can find out the scale of mapping as well as your pixel size. So here we have used Corona data, and in 1960s it was 60 lakes. In 1968, in 1994, total number of lakes was 87. It means 27 new lakes formed in between. In 1994 to 2001, there were total 102 lakes. So it means 14 new lakes formed again after 1994. And then finally in 2016, there were around 130 lakes. It means formation of 28 new glacial lakes. Although our numbers may vary with other maps also, because there are two factors. One is the scale of mapping, and second one is whether you are mapping supraglacial lakes or not. We are not mapping supraglacial lakes in this particular case. We are mapping only the moraine dam lakes or ice dam lakes only, or cirque lakes only. So increased number of glacial lakes from 1960 to 2016 could be seen here, from 60 to 88 to 102 to 130. You could see that there is a gradual change in number of lakes, total number of lakes. Although if you look at the x-axis is not uniform. Although it is shown here in uniformly, it is not uniform because gap between years are different. So overall 70 new lakes formed in the last 48 years. At 1:50,000 scale, if you improve the scale, if you go up to 10,000 scale or 20,000 scale, you can imagine that how many new lakes have formed in so many years. So increase in the area of glacial lakes from 1960 to 2016, you could see that initially it was 1.9 square kilometer, and now it is around 4.6 square kilometer. Even by 2020-21, it may be more. Okay, so it is just linearly, it is increasing, and it is increasing like anything. Yeah. So number of lake within each basin. So these are the different basins that could be identified in Uttarakhand, and different catchments are there. So you could see that how it is distributed. Distribution is also not uniform. The most of the lakes are distributed either in Bhagirathi Basin or in Alaknanda Basin. So the largest chunk of glacial lakes are either in Bhagirathi, or it is because or it is in Alaknanda. There could be two reasons for that thing. One could be the topography of that particular area. Second could be the climatic hotspot that I was talking previously. So now, like this is one important research topic that we need to find out whether these lake concentrations are related to topography or it is related to the forcings, the climatic forcing. So this is important research topic, and we are working on this particular aspect now. So this is the total number of lakes in each basins of Uttarakhand that we could map. And as I told, that Alaknanda and Bhagirathi basins had the largest number of lakes, and it is constantly growing. Okay, this is just a table which summarizes the distribution. This is lake distribution with elevation. And again, there was a very interesting result that we have seen, that generally what we perceive, like generally by logic, what we feel, that the lake should grow along the snout area, isn't it? Snout area means that area where the snout is there. It means around 3,600 to 3,800 meters. That should be the zone which is more sensitive to the growth of lake. But when we found the distribution of lakes or growth of lakes, we have seen that the growth of lakes are mostly around 4,000 to 4,500 meters or 4,800 meters. And initially we were thinking that what is the reason that why it is not growing along the snout and it is growing more at a higher height, means 4,500 to 5,000 meters. The reason could be, and the hypothesis on which we are working is that the growth of lakes are dependent on the ELA, equilibrium line altitude. So ELA plays a very crucial role. If ELA shifts, the glacial lakes also grow accordingly because that is the most sensitive zone along which changes are taking place. So it keeps moving. Okay. So these are few of the examples of proglacial lakes plus lake growth. You could see in different years how it has grown. So just see. Initially, it was 0.1 square kilometer, then 0.14, then it was, 0.17, then 0.21, 0.23. So these are the increase in size from 422 meter in length to 966 meter in length. Similarly, this is one more example where you could see those lakes. Initially, there were few lakes, supraglacial lakes, and now they have increased in size and they are growing like anything. This is for Vilangna Basin. In Vilangna Basin, we could see lake is in semi-frozen condition. Slowly and slowly it is growing and now it is in a bigger size. So there are many examples. There are many such examples of glacial lakes which are growing. Okay, these all findings just hints towards this case only that all these lakes are actually growing. However, there are few lakes like Vasukital, Masartal, Kedartal, Hemkurtal. These are few of the lakes which are not growing. They are stable. From the initial images till now, if you study, they are almost stable. They have not grown because of their topography, the place where they are located. They are not growing. They are stable. So certain lakes are there which are growing. Certain lakes are there which are actually stable. So now the important thing is, first of all, map all the glacial lakes. Second thing is to find the forcing, that which area the forcing is acting more and which area is more prone to growth of glacial lakes. And let's focus our study in that particular area only. Rather than studying the whole Himalaya, we can focus on those areas where actually forcings are acting more. That was our main priority at that time. Then we did 1D and 2D hydrodynamic modeling, and this is for the Satopant glacier that we are showing. So 1D and 2D hydrodynamic modeling, I think many of you already know that what does it mean. So when we say 1D means it is one directional. So it is along the channel we are finding out that how actually peak discharge is taking place and how much time it is taking to reach one particular point after the discharge takes place. Okay, and when we say 2D means in two direction we are finding the flow that spatially we are trying to find out that how actually water is distributed after the flooding or over the bank flow takes place. So this is the 1D 2D modeling for the Satopant area that we have done. And we got actually this study was not funded, but the most of the data was given by the JP groups because their the hydropower project was damaged. So they wanted us to do certain study. So they have provided most of the data. And as a part of the imprint project, as well as part of one of our PhD students' research work, we did this particular work and we have published this work also. So from this one, at Satopant Tal, GLOF was the glacial lake outburst flood. The discharge was estimated at 870 cumex. Then 6 kilometers downstream, it was 621 cumex. 10 kilometers downstream, it was 455 cumex. At Mana village, it was 315 cumex. Okay. And hydrograph at dam site, which is the GLOF, we have coupled with 100-year return period flood. And here we have seen that the peak flood was 2611.59 cumex. So peak discharge was around 2611.59 cumex, and peak flood reached around 44 minutes after the lake failure event took place. So why this thing is important? It means once the lake failure took place, there was 44 minutes of time for the people in JP Dam to actually take some precautionary measure or to save lives. So if we have some early warning system installed near to any of these lakes which are potential for breaching, so we can save most of the human lives, if not the property, because we have 1 hour of time or some 30 minutes of time prior to the water reaching that particular area. And there are some more analysis that I'm not going to discuss further because of the limitation of time. Yeah. So these are few of the simulations that we have done, and these simulations are for water velocity, water depth, and particle tracking, which was done. So this was a 2D analysis that was done for the Alakna River channel, and you could see that how the water velocity was varying. okay, from the from dams that particular lake site up to JP hydroelectric power project, and this was again for water depth column, and this was for particle tracking. Why we did it did for Satopant Lake? Actually, Satopant Lake is not a potentially dangerous lake. There is not much threat from Satopant Lake. But when this Kidana incident took place, there were many news in media and people were speculating that there is a chance that even Satopant Lake is also going to breach. And if it breaches, there was a high chance for complete damage to Manad village as well as to Badrinath temple and downstream this JP hydropower project also. So we did all these simulations, but otherwise Satopant lake is quite stable lake. It's a cirque lake and there are very less chance that it's going to breach. So this was our 2D analysis for the Satopant area. And these were a few of the findings. I'm not going to all those findings. You can go through our paper also. And okay, so similarly, we have done for South Lonak Lake also. I don't think that we have enough time to go through the second presentation.
Dr. Goswami, you might have to wind up now. Yes, please. Thank you.
Yeah, thank you so
much. Please. Yeah.
Yes, please.
Yeah, would you like to conclude, maybe quick few seconds to conclude your presentation? If you could.
Yes. Thank you. Yeah. So from all this, like what I have tried to show you is like we already know about what happened in Chamoli and enough deliberation is done. I have shown one more case example from Kedarnath area. I have shown a third case example from Gonatal, and then what could be done for Satopant area. There was one more case example that I couldn't show you. So the thing is, what we need to do, if we need to summarize, first thing is we need to map all the glacial lakes of Himalaya. Okay, many people can do it in different team. Second thing is we need to map also the avalanche prone area also. But if I talk from the glacial lake point of view, so let's map all the glacial lakes. Second thing is let's find out the forcing. Which forcings are acting in that particular area and how these forcings are important. Second is the topographic influence. And then if any lakes are actually potentially dangerous, let's focus on that thing. So that's what I want to conclude. Yeah, thank you. So
thank you so much. No, thank you so much, Ajanta Goswami ji, for your very, very detailed presentation. In fact, one of the examples, you starting with 1894, one of those times when, data is very difficult to actually tap or find, but I think compliments to you, and I think IIT Roorkee anyways. I mean, I'm well aware of the work Dr. Mahua Mukherjee also does in IIT Roorkee. Please give my regards, heartfelt regards to her.
Sure, sir.
Wonderful work. I think one of the first center of excellence, Dr. Ghosh, on disaster risk mitigation is in IIT Roorkee. And in fact, IIT Kharagpur has now recently launched the Center of Excellence for Safety Analytics and Safety Engineering Analytics for Industrial Disasters, sort of. But coming back to your presentation, I think some very interesting facts and figures supporting what you said, how technological intervention is the key, and we should focus on that. Mapping, of course, vulnerability analysis, definitely. But the solutions lies in the technologies, in the new innovations. And I think this is where we need to invest more in our R&D, because what was demonstrated yesterday by IIT Mandi as well, we have the solution. We just need to, create an ecosystem where they can prosper, they can be piloted, and then once the pilot is successful, we can help them scale up. Because India itself is a huge market for all of this. And I keep saying in all our interactions, on all our platforms, that disaster risk reduction is nothing short of a sector which extends huge business opportunities for the private sector also. And this is the entire perspective has to change, because disaster risk reduction for a country like ours with such diverse, vulnerabilities also, I think there is huge business potential. There is huge scope for research and development, for new innovation and technology. And I think we should focus on that as a country. And thanks to our visionary Prime Minister, Shri Narendra Modi, I think his initiative, especially CDRI, which is the Coalition for Disaster Resilient Infrastructure, I think, and other than, and also many other initiatives in the area of DRR, I think is a testimony that India looks at this subject very seriously. Any comments, Dr. Ghosh, from your side before we call Dr. Shukla?
Yeah, it is very nice systematic way presentation, giving the historical perspective of especially Gonatal and to the current day, and moreover the kind of resources that they are having, especially IIRS, because Ajanta, I know more, is belonging to IIRS Dehradun. Now, of course, Roorkee is fortunate enough to have him, grab him rather,
Yes, sir.
bringing research things, and moreover the kind of database that you have shown through remote sensing and through your how many number of lakes are increasing, how what are the size and which are not increasing, and all this information. Really, it is there already. So now the problem has happened. Now we are finding out these mines of information, gold mines of information. Now these are coming. So I would say that by sharing these things to this August platform, now there is a huge opportunity that even with this presentation also, that we have to integrate these findings, collate them, and we can repeat, check, recheck, and then make immediately that all this survey and the lakes as well as vulnerability along with climate change, all these things have to be mapped. And I think government also, even the Ministry of Home Affairs under our Home Secretary, he is taking a special effort in this direction to DGRE and the scientist group together to survey. And in the meanwhile, number of teams are now going there to visit these things, and which of course will make this things more clear. And at the same time, just before quickly, Anil also is ready, that our participants now, it is about 190 plus. So I would request that because we are having not much of time, we are having time, but already half an hour behind. So I would request that participants please write your all the queries through chat box, and each and every speaker, they will be quite comfortable enough to reply you through your privately or to everyone. Ajanta, you can check the chat box if you find some questions asking to you, and we are requesting the participants also, please write your questions, and those will be answered by the respective speaker whom you are asking. Okay.
Sure, sir. Yeah. Thank you so much, sir.
Thank you.
Thank you.
Professor Ghosh, just one comment. Can I make Surya Prakash calling?
I was
For Ajanta, just I wanted to inform that Chorabari and Gandhi Sarovar is the same lake. It's the two name of the same lake.
Yes, sir.
Yeah.
And I also take this opportunity to also, I was about to, to formally welcome Dr. Surya Prakash on this platform. Thank you so much, Suryaji, for joining us. It means a lot for you, for us to be, to have you on our platform. We've always been very inspired with the sort of work you're doing in your domain at NIDM. It has national impact and international relevance also. Thank you so much for taking our time and joining us today. Thank you, sir. And I would also like to welcome Dr. Sanjay Rana, and we will have him speak after Anil Shukla ji. Anil Shukla ji, I would like to thank you so much, Anil Shukla ji. हमारे साथ जुड़े रहने के लिए it's great inspiration. You've been watching all the proceedings on the flanks, and I think now we have the opportunity to hear you. Dr. Shukla is currently, working at the Geosciences Division as the Associate Professor at Physical Research Laboratory, a unit of Department of Space, Government of India. Dr. Shukla does research in terrestrial and extraterrestrial materials. Very interesting. He uses the tools like elemental and isotopic compositions, optical chronology, OSL, and mineral spectroscopy. The current projects are planetary analogs from Indian geological records and Holocene floods in northwestern Himalayas. With his experience on these projects, I hand over now to Dr. Anil Shukla for his presentation.
Rubabji, can you excuse me, because I'm sorry to intervene, but somehow I'm now joining through a mobile whose battery is likely to expire soon. If Shuklaji don't mind,
no, sir. Thank you, sir. No problem, sir.
We'll interact later, sir.
If the organizers also agree on that.
Yeah. Okay.
Okay, then
Please,
let me
please.
just put up my views. I'll not be making any PowerPoint.
I
But
have mentioned that you are
I
out
would,
of
yes,
Oh,
I would
yeah,
like to
wonderful.
mention my experiences with Uttarakhand.
Yes.
Currently, I'm in Aravallis. Aravallis is called as grandfather of Himalayas.
Yeah.
दादा पोता का रिश्ता हम हिंदी में बोलते हैं कि because there was no, we had the ocean in between, which actually filled up and got this Himalaya risen up from that sedimentation in that ocean. So there is a good relation physically and also culturally. Most of the population in Uttarakhand has been very closely associated with Rajasthan. So we had some interactions long before also and currently also. So now talking about disaster resilient infrastructure in hill area, two things I would like to mention. Professor Ghosh is adding a division of resilient infrastructure at NIDM, and I am also having a specialized center on hill area development at NIDM. And there is another division which called as geometeorological risk management division, where we are dealing with geological as well as hydrometeorological hazards. Now, what I see is most of the people currently, after this recent disaster, are focusing only on flood, glacial outburst, flood, or avalanches, or like that. But they are losing attention to other hazards that has actually struck the state, which are also need to be taken care. If you want to have a resilient infrastructure, it has to be safer from all kind of hazards. So we have to have a multi-hazard approach, which should include even earthquakes, landslides, flash floods, fires, or toe erosion by the rivers, sedimentation. All these are major parameters which are affecting the development and growth in the Uttarakhand state, if I talk specifically to that geographical area. In that geographical area also we have different physiography, right from the plain areas in Udham Singh Nagar to the hills and the high altitude mountains. So we have different climatic conditions, different geological, geodynamic, morphological, hydrological, and land use conditions, which need to be given adequate attention. Now let me get back to the history, as my friend Dr. Janta told about the history. If you look from the literature, we had an earthquake in 1803. Then if we look back from landslides, the first landslide which British time was monitored were landslides in Nainital, 1868, September. And again 1880, which killed more than 150 people, 18th September. And thereafter this Gonatal incident, 1893 took place, and 1894 September, which Brecht and our colleague Dr. Janta told you. But post-independence, we have been trying to work on these areas. But there is not as much success as would have expected. So if I recall from my own personal experiences, I started working on these disasters since 1990. I remember a major landslide which took place along the route to Uttarkashi, close to the Uttarkashi headquarters, which was affecting an ITBP camp. The road was being maintained by Border Road Organization. So while we were monitoring that landslide and studying and investigating that, we came across an earthquake on 20th October 1991. The magnitude was almost 6.1, and lot of damages and casualties did happen. And again, the Uttarakhand got struck by another earthquake in 1999. So series of earthquake had taken place, and frequent shocks, tremors are always felt in these Uttarakhand state, because it part of it is under zone 4 and part of it is under zone 5. Now, if I talk in terms of post-independence major landslides, actually both in the particularly, if I say leaving aside the Kumaon, Garhwal Himalaya, Garhwal Himalaya has three major river system rather. One is Yamunotri, other is Gangotri, and from Gangotri we have Bhagirathi, and third is Alaknanda. So these three rivers all have glaciers, And all these glaciers have always broken down, breched, and had lot of supraglacial, subglacial, and proglacial lakes. So all these features are very common to the nature in this particular geographical conditions or geological condition, I would say. But the issue is that when we go for development into these areas, now most of the people have actually opposed the construction of hydel projects, even run-of-the-river schemes in the Uttarakhand state. If you look at the recent event which has taken place, most of the sediment and water actually was stopped by these two power projects. And in fact, the downstream damages or impacts were controlled or reduced because of that. So we have to look into this, that tidal projects may also serve as a preventive or mitigative structures as well. In fact, we have to have some dams for flood mitigation as well, not only for irrigation or power supplies. So this is one perspective. But the other perspective, I look from the hydel project organizations like NTPC or NHPC or THDC who are working in these areas, they are actually looking around the site of their dam. They are not well considering the upstream areas from where the hazards can strike. Had that been done, a catchment area study has been done for the complete upstream watershed. Maybe these hazards could have been identified, and then they could have put some monitoring systems so that timely alerts and alarms could be given, and the valuable human life could have been saved. So this is one part. Other is that whenever we are talking about the recent events, focus is mostly on landslides, avalanche, and glacial outbursts, floods. But there is hardly any attention being given to the frequent seismic activity which is taking place into this area, and how these seismic shocks are actually affecting the glacier stability in terms of equilibrium line, what he said, ablation and accumulation zones, where it is a dynamic equilibrium and it goes on moving. Now, how these shocks actually create the impacts on the glacier? That's one question I would like to be taken into consideration. The other is that these rocks over which these glaciers are overlying, they are overlying either the morainic deposits or the hard rock deposits. And all these rocks and morainic deposits have crevices, cracks, and pore spaces through which heat gets dissipated. And even that heat results in melting of the glaciers. Now, such a melting of the glaciers, if there is some concave morphology, can form a sub-glacial lake also, which may not be visible directly by our remote sensing images. So we have to have actually both geophysical as well as remote sensing studies to find out where are our water bodies. Over the glacier, we call as supraglacial lakes. Below the glaciers, subglacials. Channels, even channels can also form. Or proglacial, maybe at near to the snout or moraine dammed lakes. Various cases have happened previously, even in Bhagirathi River Valley, which Dr. Ajanta showed you some of the cases which took place in Alaknanda Valley. I'll cite you many cases which have taken place even in Bhagirathi Valley and Yamunotri Valley also. For example, I can recall 1978 Kanoldia Ghat incident, where the tributary of Bhagirathi, it was blocked and it busted and caused huge damages in the Bhagirathi River Valley. Even prior to that, there were other incidents like Patalganga floods, which took place in 1970, very famous incident, which actually displaced almost people from 300 villages. So these events previously being taken care, we were monitoring to some extent or keeping a watch on them and informing the people through various mechanisms. So I would say that while we are discussing all these parameters, one is we have to have a disaster resistant codes, standards, and practices which are not well taken into consideration in implementation or execution of the projects, and also full scale watershed or catchment based hazard identifications and risk assessments. Disaster impact assessment is very much important, both in terms of the impact of the structure around in within the surrounding, as well as impacts on the structure because of surrounding hazards, right? So we are doing a lot of blasting, explosion, and many morphological changes even. So all these are bringing us new challenges. Further added to this is the changing climatic conditions. Now many people are talking about global warming, and some have said that on an average annual 0.6 to 0.8 degrees centigrade temperature has increased. No doubt it will lead to higher melting of the glaciers, higher discharges into the rivers, and more toe erosion by these rivers because of higher discharge and sediments. So there are a number of parameters which need to be studied. Now, lastly, I would say that most people are focusing on the long-term phenomena. Some people have said it is because of recent thaw, the glacier has broken. Some people said it is because of sub-glacial landslide or an avalanche, or maybe some crack on the glacier, or because it was a hanging glacier. So it lost the gravitational support and broke down. So different opinions are there. But I have to say that we have to distinguish, like Dr. Ajanta said, we had seen dust through remote sensing into a very specific area, not all over the hills or the mountains in that area. Why that specific area? So I would suggest three kind of factors to be properly analyzed. One is the preparatory factors, which are long term, which continue to prepare our slopes and glaciers to fail, to destabilize, and to cause hazards. So we must continuously monitor and know their impacts. For example, I said continuous vibrations within the hills. Second is the triggering factors. What actually makes it move suddenly, and that too in a period when we are not expecting that. So this February, normally glaciers are the avalanches are no doubt expected in February also. And I have a lot of records which I can show where the avalanches have happened in the month of February, because a lot of snow deposits take place. But I would say in terms of our good luck, in terms of evacuation and rescue during subsequent to this disaster, the weather was fair and there was no rainfall, and we could actually try to recover some of the people, and rest is around 204 got missing, and 57 we got, I think, recovered by now, and rest are still missing. So but these operations would not have been possible if it were rainy season, and dam authorities are normally taking advantage of this time, putting their task to the intense work, their labors, because they can extract the maximum at this time. So maximum labors were on the task, and this was the daytime when they were on the work. Whereas the incident we call as the Gonatal incident, it happened late at night. So these people were well made aware before time, and the leaning of the water in the river channels were well noticed. Now the forward challenges which we see in terms of the left out materials. Now a lake still exists near to the Rishi Ganga, and this lake, if it gets burst, will again cause a flash flood. So we have to think about how to do controlled breaching, so that this lake doesn't become a major challenge later on, because subsequently as the time will pass, the materials get consolidated, the river water gets more and more, and then it puts more and more people at risk in the downstream areas. So whether it is the hydel projects or the human lives or the highways or the bridges, all have to consider these parameters of particularly hill areas where we have the high, steep, narrow gorges, valleys, which actually accumulate. Now, another point which I would like to emphasize in terms of morphological situations, most of the confluence areas of the river tributaries, there most of the sediments will come, and there the narrow areas, they will block, and water from both the sides will accumulate there and make a reservoir, and that will again pose a threat. So number of such things are known. Most of the geologists who are working in this area, this phenomena actually is not new at all, I would say, because many of our friends who have been going to this area frequently, even I had visited Gandhi Sarovar and these areas for my field studies, but we had seen small rock falls and movements and failures, small landslides, which remain unnoticed. And as the frequencies and the recurrences occur, they result into heavy accumulation of this debris, which can block the tributaries and then create transient dams, which can burst and cause flash floods. So my suggestion, because this is focusing on disaster resilient infrastructure, whether it is bridge, highway, building, or hydel structure, must look into the surrounding hazards, upstream hazards, prevalent hazards of those geographical localities in terms of environment and geodynamics as well, and then land use and land modifications, I would say. A lot of steep slopes are created, which also cause the speeding of the water. So all these have to be considered, and we should actually, even in our working styles, consider these parameters and safety conditions. So I think I've given my views, and there are a number of other hazards also which I could have mentioned. For example, Malpa landslide on Clashman Sarovar route, or Ukhimat landslide in this area in Mandakani, and also the Fata landslide in 2001. Even in Joshimath, Lambgarh landslide in 2005 took place, which blocked the highway, and tunnel actually served as a savior at that time. So many such instances are there. So we can document those, and NIDM is working on it. NIDM has got a World Center of Excellence on landslides and also a flood monitoring cell, besides the division I have just told you, and also the Mount Hill area development. So my request would be to FICCI as well as other partners and experts to kindly help us gather the information and formulation of policies, guidelines, and procedures at the national level to the states, so that these can be brought into good practices. And let's highlight the good and the bad practices, where we failed and what we should do. Lastly, I would say share, किसी ने कहा है कि जगाना आता है उसे कई तरीकों से, दरों पर दस्तक देने खुदा नहीं आता। जगाना आता है उसे कई तरीकों से, दरों पर दस्तक देने खुदा नहीं आता। पड़े रहो सहमे हुए यूं ही, अगर हवाओं के पर बांधना नहीं आता। So let's try to tame disasters rather than getting tamed by them. And I wish all the best for this journey. And we should not stop with these webinars or exercises, but we should go ahead, as Vivekananda said, arise, awake, and stop not till the goal is achieved. And I wish you and Professor Ghosh and all the distinguished speakers all the best. And thank you for giving me time in between. And thanks to Anil Shuklaji and other speakers who are still waiting. Thank you very much.
Thank you, Surya Prakashji, for your very enlightening comments, and I think your knowledge and your experience, in the area of geometrology. I think it's what Chandan Ghoshji says. Par excellence is what you have, and I think we are very fortunate to have your views, your knowledge sharing on this platform. And I think with over 200 delegates who are connected with us, I'm sure they've turned out to be more wiser than what they were half an hour back. So thank you so much, Suryaji. Dr. Ghosh, would you like to say something?
Yeah, no, it's okay. Suryaji, he has given the account each and every item just verbatim, and verbatim means last 15 years we are together, and the prolific memory and very to the point, and whatever memory that it is a like that flow that he has given and added to Ajanta Goswami's things, and so it is a treasure that yes, an IDM is having. I must not, but appreciate rather that it is he has added a lot of new dimensions to think, especially that what is noted over there, like even Ajanta also says that they have done remote sensing and other. Now the technology and know-how is there. Entire Uttarakhand or entire Himalaya can be mapped to 1 centimeter or 1 millimeter accuracy in a span of maybe 1 week, with each and every account of the glacial lake where it is there. And in fact, after Nepal earthquake they have done, after 2011 earthquake in Japan, entire country they have mapped in few months of time. So we have got all those equipments in our country. So country is now gearing up to map all these things, and which should not take more than 2 weeks time to get each and every account with all dimensions 3D. And another point that I would like to highlight, that in places where, like as Suryaji mentioned, that it is resilient infrastructure means it's not concrete or dam or anything. It is all these things, climate change and all watershed and even all those glacier that which are classified, even to the extent that where there are so many prayags are there, and if you see Nanda Prayag or all Prayag, there two water flow is meeting there, but naturally we have not done anything to increase the water flow at the Prayag. Even in cases wherever it is required, based on this first basic information through satellite as well as through drone or through airborne LiDAR mapping, we may have to go for even blasting some of those portending dangerous even snow or glacier if they are in a position to fall down and blocking our river, which has happened, which will be happening more and more. So that is why that the survey that which is going to be taking place, which is under serious consideration to go for this survey, based on that, maybe we have to trigger something, blast them, fire them, some of them, which are dangerous, like in this case, as Ajanta has shown, more than 550 meter, which is estimated that the portion that fell down, if we are able to see through our surveillance that some is dangerously, they are about to fall down, we have to maybe fire them to, or we have to pierce them to fall down systematically, the way we do systematically implosion or blasting of some of the mines or buildings that in Kerala that they have implosion, that through that they have demolished that thing. So even we have to go for such kind of measures based on the data, based on the monitoring report. When something is going to fall down, then we have to fall down forcefully by thorough observation. Even this we are going to give in our suggestions. So anyway, sorry, Anilji, you okay.
No, sir. Thank you, sir. Shall I start?
Yes, please. Over to you, Anilji. Thank you.
Okay. Very good afternoon, everybody. So let me, before proceeding for my talk, I would like to let me first share my slide, I think, correct? Are you able to see my slide?
Yeah.
Okay.
So, let me express my gratitude to the organizers, especially NIDM and FICCI, and especially Dr. Ghosh, who have provided me opportunity and myself in front of this august audience, who are the real workforce of the country, who are driving the development of the country, of India. So here I would like to tell that I am a basically experimental research scientist, but also go quite often in the field because I have my training in geology. And
Because my research, if you see, as Rob mentioned, I am a person who is working on fundamental risk problems and starting from a spatial and temporal domain from beginning with the solar system to present day. Of late, my interest in Earth surface studies. So I handle a lot of more sophisticated instrument, mass spectrometers to date the rock or understand the fundamental process, how the rock is evolved or formations. And at minerals, all this scale, as Chandan Ghosh was telling that day. So that is because that's why we've been working doing Earth and planetary research. In past 25, I'm located in PRL. And as you mentioned, I'm past few years working on surface studies here. And I got involved mostly due to, I can say, 2013 devastation. That was a triggering point and to got me into this project, this type of studies with my colleague, Dr. Senior Scientist, Dr. Naveen Jiwal, and at that point of time, and got interested on our surface processes. So as this is the talk today, I have just chose because I work mostly on hydrological events. I told you Uttarakhand in Indian Himalaya, and we try to understand why it is happening, how it happened at that point of time. So the need or basically theme is resilient infrastructure in Hilly area. And Hilly is mostly the dynamic Himalaya to me. Your theme avalanche, GLOF, debris flows, all are basically related to me as a natural events, water driven and ice driven. Okay, so now coming back to Himalaya. Basically, this is the, just to recapitulate, we are working on our dynamic Earth only, which has evolved from around 4.5 billion years ago. And now you are seeing Himalaya, everybody talk about the dynamism you can see by earthquakes. But that is a signal Earth is, this plate is, Indian plate is subducting below the Asian subcontinent and it's still going on, which started its journey around maybe 71 million years, Peter Molnar work. And it first collision took place around 55 million years with the Tibetan plateau. So this is schematic, this is the dynamic, it's still going on, and still we are say by GPS measurement, all heights are increasing, Earth square covering, big tremor will come. So this is a broader way. We know Himalaya is very active, and we have to live with this because because this is a natural processes going on. We cannot stop them. So the infrastructure development is a really need of the society. So the natural processes are basically have to be the natural dynamic system of the Earth. So they have to connect it, but they become natural hazard when your loss of property or life you got involved in that, in the process. So that way I look at it, and because I work on million scale, time scale, now of late I started working on late quaternary period, mostly in last 20,000 years, records with my, as I told you, Dr. Shubra, was PDFBB. We try to understand, started with my journey from there. It's a beautiful landscape. Just want to impress upon you how the Himalaya has come up with this collision. This is a Tarai belt, and you are seeing a lesser Himalaya, lush canopy of the trees and all. And you know, again, higher ups, you see beautiful plains. Now we are glaciers, higher. So such a beautiful terrain, we have such a process are going on, natural process where active weather system is interacting. And we are talking natural hazards because these are the natural process to me. These are natural hazards with water or wind acting on the dynamic Earth. They are creating a now disaster because I just told you. So just I want to impress upon you this surface is happening due to the Earth dynamics or whatever natural hazard. We are having these issues. So, but we have to live with it. And we have to how to, as you have tame, understand, monitoring, a lot of discussion last 2 days. So I am not that field, but just to build a resilient structure, we should understand the basic property of the terrain first. So accordingly, we can plan whatever we are going to do here. So just to give a few examples what I have contributed. This is here, I want to show in this slide, you see the Himalayas, you see Gangetic Plain to Shivalik, and this is a height by height resolution. So you see up to 5 kilometer higher Himalayan peaks are there than Tibetan plateau. So whole your Indian summer monsoon, this is a precipitation in the bottom. You see how with distance we take from south to north, how it is changed. And it's all the moisture dumped near the higher Himalayan and lesser Himalayan boundary, which is main center thrust in geology. So all this activity with water and technology is happening in this domain only. So this is, I just impress upon you of this dynamic here. You can see the DEM image, we have published this work. And you find the earthquakes focus in the Salaklanda and Wagedri. This work we published on Uttarakhand tragedy. And we found that this, we see the MCTs, sorry. Just 1 second, sir. Pointer. So this is our MCT, where I'm talking about relief changes and whole. So these flush usually occurs high focus rainfall on the face of the orographic barrier. These are the orographic barrier, and they activate tectonically and south of the main central thrust, which are the hill slopes and nearly threshold of landsliding. There's already in that angle of engineering slope management. So we had already had a precarious balances there, and the landslide caused by the increase of poor water pressure from the steep slope in the south of the MCT led to the obstruction of streams, courses, breaching of these obstruction, and highly peak flood carrying voluminous amount of sediments and downstream. So this is a Alaknanda Valley, most may have worked. And this is an example of 2013 where this event of cloudburst happened, and all these dotted circles, you see the area got affected. And this is a Srinagar town, which was a daily discussion. It is Goswami also in Gonatal event and all. I just want to see you what were the flood records in this area. Just going back, we have fortunate how we can do is lithotectonically. If you see our Himalayas, we can classify these rocks from south to north, lesser Himalaya in geology based on their rock characters, rock compositions. And then we can talk about how they are getting weathering or erosion and dumping the sediment in the records. So I try to use those records and understand their pattern. So as I just to recapitulate already, Ajanta told you, is I can recall only 3 major flash flood events which are well documented, including Uttarakhand recent tragedy. One is 1993, which was due to already Gohanatal event. Only by impress upon you, when landslide happened, at that time, district magistrate anticipated that will happen. So he sent that particular person who named Dr. Goswami told to install all these lines and how to do early warning system. Those days, there was less infrastructure. And they calculated how much time they have to do this job. And exactly after 1 year, that lake was reached in 1994. So that type of people were there at that time. That's why we can save a lot of property, no life loss at that time. And then again, 76 years later, 1970, this famous flood, we got activated again at MCT, at that filled up the Gehana Lake of 1894. And the flood caused large scale destruction in lower reaches, including what Ajanta told you. So this is a famous, already he showed you 1894 picture. This is in 1970 flood asphalt material, which we published. And these are land records here. This is still that 1890 flood here. This is a 1970 flood record level. It reaches in the valley. And now it is in 2008. This is the Gohana Lake conditions. This is already full. So you know water is there. So this is a famous picture in geology by him and Ganser, 1935. They are talking the water is there inside. And they are talking about this lake formation. So this is a tragedy, you can recall, of Uttarakhand. This is a Khiro Ganga Valley. This is before tragedy, this is after tragedy. So you can see why this magnitude indicates sensitivity periglacial regions in the Himalayan short-lived intense climatic event. Small event, so much material came. So these valleys are very sensitive to any change, little bit changes are there. You want to interest. So you may remember Vishnupur Hyderabad large damage was there at that time. Now coming back to Srinagar town, this is a beautiful Srinagar town valley. You can see full of triases and development. And this is our tragedy pictures at those time in 2013. A lot of material, muck is born in the ITI building, all the damages, amount of muck. This is cloud, whatever cloud was, sediments came. But we worked and we found these are the material. If you see the dam projects we're working on, and they have dumped the material, and we just try to analyze which material is lying in these houses collected by the river. So that calamities increase manifold in these houses if could have managed these loose material already by the agencies, and be able to, based on my geochemical analysis, I able to say that whatever material was there, that is the dumps, they have about this much. You see, I can read here. The two Gondal are there in barrage, and we calculated that 47 to 43% material was migrated, and they contributed in the sediments which got deposited in these buildings. So what I can say, we can develop infrastructure. We should keep in mind all these things as a precautionary before proceeding further. So this is the first time demonstrated that anthropogenic condition of sediment in hydropower mark aggravated the downstream flooding in Srinagar town of Garhwal. Not only the flood came in Kidana, that lake got dammed, that material came here. I cannot find that signal that much. But this is a local material had driven these pictures that I showed you here in these sediments. So this is an increase by anthropogenic activity. So then that way they started, okay, what is past flood record, what Dr. Joe was working, and we found in the Garhwal Himalaya, this near Alaknanda Valley, we have very old records, and last 2,000 years, we have many events we dated, and we found their contribution because the monsoon system activating, so higher Himalaya and lesser Himalaya, how much contribution we are able to identify which is more active and these are that. So this is again further ongoing time, Satluj Valley with my PDFs, Dr. Shubhra at that time, and we work on that. And we got the Satluj Valley near Rampur and all this area. We want to, there are four major flood phases were there from 20,000 years. And geochemical suggest these events are monsoon dominated area only. This is like a landslide metric condition were existing because GLOF is only the glaciated paraglacial zone only. We cannot find that time. So this study, first time we demonstrated, there is a coupling between Indian summer monsoon and mid-latitude westerly. So during the negative phase of Arctic oscillations, that time we were able to conclude on that. But this is basically these processes are synoptical connections are there, which are triggering this type of. This may happen anytime, it may happen maybe sometime later. So we have to work with this. So this is just to impress what is North Atlantic oscillations. These are basically two pressure centers are there at Iceland and Azore. One is positive and there is low pressure and high pressure. And there is some changes is there. Due to that strong winter like in the US and all, this cold winter come down and try to migrate. That may interact more. That's why we have this type of phenomena. We have to further work upon this more. Now coming back to Rishi Ganga, as a geologist perspective, everybody seen this picture. I see this picture in 2017. These rocks, if you see, so much stress are there. These are the foliated plains of the rock, bedding plains. They are highly crumpled, and over that, a high burden is there. Already, you see, 2007, this crack is visible here. This way, already visible. I don't know if this how ice is there, or I'm not expert of glaciers, but I just impressed. You see the layering, all the same rock. These are the black color. These are different. Rock strength is totally very friable rock looks like to me. That may be which you should see very carefully when you Planet Lab exercise by Dr. David Pitley and all. You see this material. I don't find there's a glacier is there really. I doubt sometime. See me, this is a glacier or snowpack only, but it have come down. Maybe this frozen ice and come down in the valley and make the demonstration. So if you see the geomorphology, this is from 5,041 meter to coming to Tapovan 18, so much drastic different pockets sediment must have deposited, and how much energy has been dissipated there, and we are able to still that damage we are seeing Tapovan. So we can see how much is there. So coming back to geology, you see, we know we are working MCT. Coming back again to talk the geology. This is MCT here. Tapovan is here. You see MCT. Trishul. And these are rocks are basically I talked about. These are basically there are two types of rocks are there. Basically, most are pellitic micaceous or clay type of material, which are metamorphosed and got and crumpled and got it. So these are absorb water in these crystal lattices. And whenever the harsh climate, they may behave and they may crack. So instead of a chicken and egg problem, to me it looks like a rock property and overburden it may happen. So these are very sensitive areas. We should like to when planning all these things. The rock slide is basically rock slide to me. This is water and the shear strength of the block changing as a force of gravity. When your shear strength is increasing, shear force, then you are sliding down or slope. These are very high slopes. So where you are bedding planes already there, so they can slide easily come down. That type of you should keep in mind all this. So coming back to resilience infrastructure, as I want to impress on, the environment is unstable. People have been learning to deal with environmental risk and change it. Natural agents as their processes, glacier, volcano, flood, earthquake, or landslide, have the capacity to developing a natural hazard when people live or have their property comes into play. So need our having detailed geological, geomorphological investigation, macro to micro level, should be done for all big infrastructure project like dam, not only the site, but urban catchment, as Dr. Surprakash was mentioning. And carrying capacity of the area should be also a major consideration. How much load we should get the value there, and detailed environmental impact analysis considering natural disasters. So design of any infrastructure should take precautionary measures. First before starting the project. The most important, what I observed recent involvement in somewhere in Hilly region, before proceeding the high value infrastructure project, a slope management plan should be adopted and implemented in parallel. For example, hill cutting is a general problem. It creates instability of the slope, but it is a basic necessity of creating space in the hilly terrain. We don't have spaces in Himalayas. So project should take care of all the aspects like geology, geomorphology, environment, as well as social fabric of the area. For example, during road widening, a general realignment as well as the tunnels get more attention while preparing the project. This is due to a standard definition of the quality by special laws and technical regulations. But the slopes cut are backfilled or passing through mountains or slope rarely attracts detailed study except at the places where slope failures, landslides, which is common after the construction, slumping, sinking. So anthropogenically induced slope problems are a result of many aspects: increased weight of the hill slope from hill slope, overstepping, removal of slope support in road cuts, alteration of surface, runoff paths, and enhanced runoff areas. It is observed that small scale slope involves the construction of roads, so the slope angles are determined through experience only, or sometimes directly based on technical standard without considering the stability parameter of the slopes. So it is a high time, as I want to say in this forum, because industry is involved, this federation. So they are the basically driving force. They have taken the projects. They are high time to use the relevant theories, available computation knowledge to manage slope management rather than just by experience in a sensitive terrain like Himalayas. That much I want to say here. But I can salute our engineer. The structure is still standing. I don't know why we are saying the dam had washed away by media. This structure is still in. But so much volume came, it came from side. This guy, you see the fill, because they have not anticipated how much material will come. I just want to last acknowledge my colleagues and thank you all for your kind attention. Thank you, sir.
Thank you, Dr. Shukla, for your very detailed presentation. In fact, you raised a very at the fag end of your presentation, a very relevant point with something which I was also observing in all the presentation in the last 2 days, that dam actually did not get washed away completely.
Yeah,
just stood there, and of course, when dam is of course built, I mean, I'm sure there are civil engineers. Whenever something like this is constructed, I'm sure from a layman's point of view, a certain amount of resilience which may anyways incorporate in a structure. Yes, maybe not to the level where we now want them to.
yes.
For example, in Odisha, the transmission lines, the generation facilities, power sector gets affected almost on an annual basis because of cyclones. Now, the regulators have chipped in. There are transcos, 3 transcos there. The regulators have chipped in that the maximum speed of wind, which the velocity, which has been sort of measured, is over 305 kilometers per hour. Now, as per the previous regulations, the maximum capacity of of those equipments which are installed, they were resilient to almost 250 kilometers per hour speed, which was again on a very higher side. But then the nature's fury is such. So now, when you are talking about sustainable, resilient infrastructures, maybe we need to think on 350 or 400 kilometers per hour speed. Now, when we are almost recreating, It's not renovation. It's about recreating the entire structure or entire infrastructure again. So I think there are various aspects. You also, the hill cutting aspects which you mentioned were very relevant, and I think they form the basis, of any upcoming infrastructure development. Now, very relevant point, sir. Thank you so much, Dr. Shukla, for your very interesting presentation. Dr. Ghosh, for your comments, please.
Nicely, Rubab, that you have given the cover up, especially some of the very interesting slides that Dr. Shukla has shown. That just before I was saying that when earthquake in 2008, just 3 months before Olympic Games in China, Sichuan earthquake occurred in May, 26 May. There are several landslides occurred. Of course, 70,000 people died. And in the last week of May, and when it has occurred, many landslide lake formed.
Yes.
Then when those thousands of landslide lake formed, they did the survey. They found that so many lakes and monsoon and rain, and then they will create many cascading flood. And they cannot overnight change the river course, or they cannot do river work at that time. So what they did at that time, they located all those things, and then they have made a dynamite, just burst them, directly going there and locating them so that they can deflate the water. So far in our discussion, even 2 days, and even many other discussions, probably a time has come now to take such kind of measures also, because when we have to work not only as a doctor, or like doctor of engineering, or geotechnique, geology, and all observation, all pathology that we have to look at. So far we have been looking into the pathology, but especially we have to see that which are the protruding one, which are likely to fall down, let and fell them down. So that kind of surgical operations we have to make with those dangerous or potential the lake that which are going to burst, or where water is going out of in the danger mark. It is not that we are checking through satellite like Parichu Lake we did. Those things are gone now after 15 years. Now things are dynamically things are changing like anything. Accordingly, we have to make our push our surgical knife, rather what I am saying in a blatantly. So we have to now not that to see that, okay, this is dangerous, slope is very steep. If slope is steep, we have to stabilize them, or we have to cut them, we have to flatten them, we have to stepping that we have to make. So and taking care of disaster resilience, especially for such kind of infrastructure, we have to make it, because there are a lot of things we get out of them. So in that case, now consensus maybe is that which we will take care, that we have to go into all the pathological things, that whatever geology, geomorphology, underground, where our next speaker, Dr. Sanjay Rana, I would say in one word, like he is a lal pathology, like you can know, lal pathology we know all over the country. 200 plus tests are being done. Even today morning, in fact, I was there. So anyway, it is just only in a lighter side what I would say, but we have to know all this information, and then we have to sit together, all together, that what kind of operation is to be done to save our infrastructure. And you have rightly mentioned about the infrastructure has not failed in most of the cases, because we are very much strong enough, very much in our analysis and in our design and basics, which we want to teach in geology, engineering geology, or even geotechnical engineering. So that way, most of the dam structure they are safe, but the kind of impact that caused some cascading effect causing, here not only such surveying and data we have to have, but we have to also see that what kind of operations is to be made before danger comes and before it goes out of order, out of say control. So this is what I would like to. Thank you very much for.
Thank you so much, Anilji, for your presentation, and thank you, Dr. Ghosh, for summing that up. In fact, I realized, like yesterday, it was IIT Jammu and Mandi. आज IIT Roorkee का दबदबा है, and our next speaker is Dr. Sanjay Rana, who also happens to be from IIT Roorkee. I hope, Dr. Rana, yes, we can have your visuals as well. A very good afternoon, Dr. Sanjay Rana. Thank you so much for joining us on this platform to share your vast experience. And as I see, as I was on a lighter side saying that, IIT Roorkee has taken away, the majority of slots today, and this also is a testimony of the great institute it is. Apparently, it is one of the oldest engineering institutes of the country, the oldest, and I have been fortunate to be associated with some key fellows there. In fact, including Dr. Mahua Mukherjee, another great, very enterprising mind in the area of disaster risk reduction. So without taking much time, I would quickly like to introduce Dr. Sanjay Rana, who's the chairman of Aqua Foundation, Delhi. He's also the owner of Parson Overseas Private Limited for the past 20 years, has worked in Department of Atomic Energy as well. And of course, his former education in the area of geophysics was from IIT Roorkee from 1987 to 1990. His skill set includes specialization in the area of geology, geophysics, and earth sciences, with being endorsed and recognized by several renowned personalities on the subject globally. So it's my privilege to invite Dr. Rana to make his presentation and enlighten us further. Thank you. Over to you.
Thank you very much. Thank you for a very generous introduction, and my very special thanks to Professor Chandan Ghosh for giving this opportunity of presenting it here today. Honestly, I have been attending this entire session, and my subject is completely different, although very useful for whatever has been discussed, but it is different. So I will just, without taking much time, and I'll keep it short also, because I think we have already overshot time. So I'll just start with my presentation. Okay. All right. So I think you can see my presentation now. Okay. So I'm basically going to talk about role of geophysical method for resilient infrastructure in hilly areas. I have been introduced quite liberally, so I'll not spend much time on this, but yes, I have the privilege of graduating from Roorkee. That time it was University of Roorkee in 1990, around 31 years back. So it's a great privilege to be associated with that. And I am the founder director of Parson, which is basically a geophysical company. We are the largest, but more than that, we are known to bring new technologies from time to time, right since inception actually. So GPR was introduced by me in the private sector in 1996 for the first time, and since then the journey continues. Today we have offices in Bahrain and Saudi Arabia, our own offices. So we are an Indian multinational in that sense, and we are working in more than 14 countries around the world. And I am chairman of Aqua Foundation, where AF Academy is our main branch, which gives trainings and knowledge sharing platform to various people. So as I look at it, as I always like to start my presentation with this famous quote by Sri Visvesvaraya, who said, the engineer's first problem in any design situation is to discover what the problem really is. So once we are talking about, the resilient structures and ultimately infrastructure, resilient infrastructure, be it in any area, and especially in this particular case, we are talking of Himalayas, which are a very, very young mountains and fragile ecosystem. So ultimately, whenever we are designing that, I think our first problem is to find out what the problem really is. And unfortunately, till recently, this is how we deal with our problems. That is, we are trying to do things the way we are accustomed of doing it. And even if someone is saying, let's say, tools are available, use them, don't be scared, your job is still safe, we say, no thanks, we are too busy. So basically, we are too busy to improve. Now that is where my presentation comes in, because most of the time we are still working in all these areas in very conventional methods. We are not making use of the latest and the new technologies. Now the fact is that application of geophysical methods for subsurface exploration, the experience clearly demonstrates that the geophysical surveys are assuming a great relevance to manage the underground environment and to adopt new strategies for the mitigation of geological risk. Of course, like what I am going to talk about is geological risk. I am not obviously, I cannot talk about, for example, the natural phenomena which takes place, but any risk is basically a multiplication of probability of failure and the consequences. So we are basically going to talk about reducing the consequences of that particular failure. So the capability to explore the subsoil with a multi-parameter approach are the key of success of engineering geophysics. And that is available today. We have a lot of things which are available. Now, I think this is something which will be very interesting for Dr. Chandan Ghosh to look at, because he started by saying about doctors and then surgical methods, surgery, and obviously pathology. So here I say we call ourselves medical imaging professionals. So what all you see are basically images which have been created by using different kind of rays and waves of the human body. Here we are looking at ultrasound, here we are looking at X-rays, here we are looking at MRI and CT scan. And this is how we have tried to find out what's inside the human body by using different kind of rays and waves. And compare these images with the images here. Here we have tried to find out what's inside a particular structure or inside the earth using different kind of rays and waves. So why geophysics is being used? Of course, the comparison comes right from there, low cost. So the difference between actually a surgery and a X-ray. So low cost, rapid coverage, large areas can be covered very quickly. It gives continuous information. So for example, most of the time, as I said, traditionally, we are relying only on the boreholes. So if you're just doing boreholes, between the boreholes, whatever is happening, you are actually extrapolating or interpolating. You do not know exactly what is happening between the boreholes. Like, for example, there can be a void there, there can be a pinnacle there. This is limestone pinnacle. You really don't know what's happening. So geophysics, on the other hand, gives you continuous information, which helps in optimization of drill holes. It does not replace drill holes. Now, that's one big problem you can say, which has happened between, traditional practitioners and the modern practitioners. Traditional practitioners somehow feel that, we are threatened because this technology is taking over us. That's not the case. This is helping the traditional practitioners for positioning their wells in much better way, optimizing them, and minimization of surprises in the process. Of course, it is good for early stage application, for better planning and smooth execution. So when we talk about investigation, it's a methodology of acquiring advanced knowledge of the site conditions so that a techno-commercial viable project layout can be developed. The issues which we are facing today in most of the projects, and whenever I'm saying most of the projects, I'm talking mostly of the tunnel projects which are taking place, the dams which are being constructed, or big road networks which are being constructed. Adequacy of investigation of underground project under question. That is quantity, quality, and budget. So the problem is that world over, 3 to 5% of the project cost is being actually spent on investigation. In India, if you have to take a guess, I don't know what your guess would be, but it's around 0.75% on the average, 0.75% of the project cost. Worldwide average is 3 to 5%. And here we are talking of the projects in difficult conditions like Himalayas, where it should be on the higher side, that is 5 to 7%, we are at 0.75%. And that is why most of our projects go for cost and time overrun. Then optimum time to be allowed for investigation, because we have an urge to rush into construction, because construction is something which is actually visible. When the investigation is being done, it is not really visible. Construction, the big machines come on the site, ministers come, cut the ribbon. So there's always an urge to rush into construction, and we do not complete our investigations properly. And of course, technological improvements required to be brought in, which we have problems like old specifications, RFPs, standards. Changing the standards first. You bring any new technology to any of the organization, the first question is, where has it been used? Is it already in our departmental documents, etc., etc. So you're dealing with so many of these problems. If you look at classes of delays, contract related, law and order, geological surprises, natural calamity, and others, Geological surprises is something which can be completely taken care of by improving on your investigation. So quality of investigation, quantity and time basically leads to less uncertainties and less cost and claims. Now, when we are talking of hilly areas, all these kind of areas, we are talking of difficult ground conditions. Fact is that expertise and engineering solutions are available for dealing with any or almost any ground condition. The problem is meeting the unexpected or uncertainty of the ground condition. And this is just one example. This figure I have taken from International Tunneling Association, which says that even a comprehensive exploration program recovers a relatively minuscule drill core volume that is less than 0.0005% of the future excavated volume of the tunnel. You are making all your interpretation about the subsurface condition based on 0.0005% of the information which you have derived from the subsurface. Now, once you are making a structure based on this kind of information, and you still expect it to be resilient, you still expect it to really take the forces which come onto it, that's something wishful thinking, what I call it. So basically, this is what it is. A smart decision maker is that basically we are almost taking all our design decisions with our eyes closed. So the next question is, how much investigation should be done and how it should be done? So can we actually drill every 1 meter and turn the ground into Swiss cheese? Of course, that's not the solution. So that's where the geophysics comes in picture. And here, as I have shown this picture also, just like medical imaging, we are doing imaging of the subsurface. So for example, this is a shear zone in a otherwise good bedrock. This is the bedrock, here's a shear zone. Now, if you don't detect this shear zone before you get into your construction, you are getting into big problems. There are concrete bars in a cement slab. These are underground pipes. These are cavity in sandstone. These are fracture zone in dams. So the basic theory is that you are using different kind of rays, waves, and fields to find out what's inside the earth without actually drilling and cutting. I start with very basic heliborne geophysics. Now, heliborne geophysics is something which you can do from a helicopter. Large areas can be covered very, very quickly. And as one particular speaker was talking about mapping this subglacial lakes and things like this, these days you have drone-based GPR. You actually do not even need to go there physically, right, on foot to do this mapping. You can even use drone-based GPR. You can use, for large areas, you can use this kind of heliborne equipment to map large areas and look at the weaknesses, discontinuities, and subsurface mapping of these areas. So these kind of opportunities exist. Here you can see the information up to around 700 meters from top is available. Wherever, like you're flying your, this is the one line, you fly number of lines, you can practically make a 3D model of the subsurface, showing you exactly where the problem zones can be. Then there are different methods. I'll not really get into details of it because time has actually run out, honestly. So seismic reflection is another method which can give you complete stratification of subsurface. Seismic refraction tomography, it is used very frequently to see, for example, where are the weathered bedrock, where are the weathered zone, where your rock is. You can even find out small shear zones or small weak zones inside in the subsurface. This is the depth scale and this is the distance. You can find out very, very small shear zones using this. It obviously can be done across flowing water also in rivers to find out your bedrock channels and things like this. In fact, after Kidana tragedy, we were assigned this job by Archaeological Survey of India to map the complete, debris, to see the wall thickness of the Kidana temple. We use GPR, we use seismic refraction, and we use ERI to do all this mapping after the Kidana tragedy. It was very fresh that time, unfortunately. It was a pretty bad scene there with a lot of bad smell. So electrical resistivity imaging, again, to find out, for example, fracture zones. Okay. Now, these are the weaknesses of subsurface we are talking about. So fracture zones. Now, this is a big shear zone here. So this is a depth scale 1040 to 860 meters. So this is a total vertical scale. This is a length around 450 meters. And here is the shear zone. So once you are able to map these weak zones in the formation, be it in the upstream of your project or where you're putting your project, that basically helps you mitigate the risk which you are otherwise encountering. Other example is 500 meters of investigation. This also can be done across the dam, across the flowing rivers. This is a wonderful example of the usefulness of these techniques. This particular profile was done by me, like I myself was there in 2001. It was for a project in Nepal, and they almost had chosen this dam site. Okay, they had chosen this dam axis based on some 17 to 19 boreholes they had done, and they had found rock. This is rock. This yellow line is the rock. And then we did this investigation and we found the shear zone sitting right here. Imagine if this investigation was not done and they would have gone ahead with construction. All right. Now that is the kind of risk which you can actually avoid by getting good quality continuous information on your projects. Similarly, this is an existing tunnel, and sometime in the existing tunnels you see seepage, etc., etc. Now it can be coming because of some weakness behind this. So it was done from the tunnel roof, and you see this is the bad zone here, and water was actually seeping from here. So if you actually drill here, you will end up into a formation where you will not be able to do any grounding. It's a very, very compact formation because water was coming from here, taking this particular path. So very good example of how these techniques can be very useful for this. This is another example of slip surfaces for the landslide. So this example is the landslide studies. It has been done by one of my friend, again from Roorkee. He was my batchmate. Now he is in CBRI Roorkee, Dr. Kanungo. And here you can see these are slip surfaces which he has beautifully mapped using electrical resistivity imaging. So very, very good for landslide studies to see the potential landslide areas. Okay, there are so many of these case studies. I'll not get into that. Similarly, for a particular area, you can find the shear wave velocity to see the liquefaction potential of a particular site and how it will behave under earthquake. Cross-hole seismic tomography, again, is a very interesting technique to find out what's happening between two holes. So here are 5 holes which were done, and now between these holes, tomography has been done, and this fault, which otherwise was not detectable just by direct drilling anywhere, was detected based on this seismic tomography. So now you know what is the geological feature which can create risk for your project. This is an example of detection of a large cavity in the subsurface at a depth of around 235 meters we are talking about. This is from Bhutan. And this cavity was as big as 85 meters by 60 meters. Now, existing structures also can be investigated very effectively to see whether they are having some problem. Let's say you have a dam. So this example I'm going to show is of a dam. It's 450 meter long. And we did this L section tomography in the dam. And once you do this tomography, you're able to see that there are the weak areas inside the dam body. Now, if you leave these areas unattended, now these can be problem of a disaster because this dam actually is very, very weak from these areas. So once you have this kind of an X-ray of this dam, and this entire L section tomography was done in 4 to 5 days of time. All right, that's the speed of investigation we are talking about. Similarly, you can do it in the cross section from upstream to downstream phase, and now you know where the weak zone is. So you can actually do the complete X-ray or ultrasound of your subsurface structures to find out what's happening. This I will just skip. This is looking ahead of tunneling. So now, whenever we talk about geophysics and geophysical methods, there will always be a section of people who will say that we use geophysics there, but we were not able to get very good results, etc., etc. So I always put this slide, that is limitation and reasons for failure, wrong tool selection. If you are using, for example, this kind of a knife for shaving, you are likely to get cut. So similarly, if you're choosing a wrong tool for your investigation, the chances of failures are very, very high. Method lacking desired resolution. For example, if you're using electrical resistivity imaging to trying to find a void of 1 meter by 1 meter at a depth of 100 meters, it's not going to happen. Geology ignored, calibration of the equipment ignored, only single tool used, wrong initial modeling inversion, and inexperienced practitioner. These are the reasons which lead to failures of these projects. So to conclude, these techniques are very quick for assessment of subsurface conditions in non-destructive manner. They give detailed and continuous information as against drilling, and they're critical for site investigation in hilly areas and actually should be the first step of investigation program. Detailed methodology should be worked out based on details of the problem and objectives. Thank you very much once again for inviting me for this small talk, and this is my contact details. And if the time permits, you can definitely ask me questions there. Otherwise, please feel free to write to me on my email ID, and it will be a pleasure to revert back to you. Thank you very much.
Thank you, Dr. Rana, for your a very crisp presentation. I think it was very meaningful as well. The one of the aspects which you reflected upon, the geophysical aspects, I think they make so much of sense, in planning, as you said, resilient infrastructure. And I think mapping is one of the key areas, when you're doing vulnerability analysis. I think it cannot be, in fact, even thought about without the, without, vulnerability analysis cannot be thought about without mapping. And I think you're doing some phenomenal job. I think your experience on the subject and then parson your initiative for the past 20 years and your presence in 14 countries says it all. I think you're doing great service to not only the nation, but globally. You have your footprint, and I must congratulate you for the great work you've done. Thank you so much. Thank you for being on a platform, and we look forward to more such interactions where, as we earlier mentioned, that we have a very strong relationship with NIDM now, and other important stakeholders in the country like NDMA and CDRI. And I think CDRI is a very, is like a shout out to the world by India that, we are taking lead, not only regionally, but globally to talk about, to discuss out in the open, to create a platform where knowledge can be exchanged, the best practices can be exchanged between developed, developing, and underdeveloped countries on resilient infrastructure. Because if any impact, any disaster hits or affects any infrastructure in a country, maybe in Africa or somewhere in the Middle East, I think in today's liberal times, I think it affects every country, not only in that region but globally. Something what happened in China, something what happens in US would affect India in a way as well. So I think it's about coming together as a world to build resilient infrastructure. And I think initiatives and technologies and initiatives like yours, I think help us go closer to our goal and walk to that path of common understanding. Thank you so much. Over to you, Dr. Ghosh.
Each and every colorful, not by color, rather the insight that Dr. Rana Sanjay, that over his 25 years of experience has shown, that what kind of, especially his last slide, that what kind of tools to be used. So each and every slide and each and everything so far for the entire 3 days, all we are talking from satellite imagery, looking at superficially where things are looking, what is the color, but seeing the color inside, real color of the earth or real color of the hills area, even tunnel inside where problematic tunnels are there, which through geophysical survey, that the kind of examples that he has shown to I think the entire, it has given us such a wonderful insight that probably the presentation, each and every slide, that the way that you have represented, that how it can support as well as complement some of the flaws that we go into the conventional investigation. And so that really it is highly valuable, invaluable. I would not say it is a suggestion, rather it is the aspect that to be taken into while in the entire 3 days of sessions, that what we have seen over the ground or the glacier or the lake through satellite imagery, but what you have shown through whatever the tomography, electrical resistivity, seismic reflection, and there are, in fact, there are number of such training program that even some are ongoing also for the professionals that this Sanjay Rana and his group of experts, which are stalwarts in their field. So silently they have working and several projects that they have been working on. So it will be a excellent combination of underground investigation things, direct, indirectly, geophysical, especially, and then overground information, collating them and then integrating them will be the real work that we must do to understand the nature and the way that it is likely to behave. Despite we have got the voluminous say data base that created on climate change and its impact and the kind of temperature that it is changing, ultimately it is the world that we are living. So the whatever that we are taking from the nature, we have to work accordingly, because people are living in minus 30-degree temperature also, people are living in plus 55-degree temperature also, cozy living or whatever comfortable living. So the world is like that, and we have made our living comfortable whatever extent possible. So at the end, I would say that this is the last presentation. Yeah. So I think this is a wonderful addition. That's and also we compliment to Sanjay for giving such a insight inside the ground, giving a really way forward to take this goal of this meeting or this training or this kind of interaction to much deeper roots into our way to look at whatever is happening in the Himalaya and with our infrastructure, not only in Himalaya, everywhere in the country.
Absolutely. No, I think I couldn't agree more with you, Dr. Ghosh. I think, and I think this entire, the initiative of FICCI and NIDM, I'm not boasting about it, but I think, as I've been saying time and again, it's a very timely initiative, and where we have got the best minds in the business to talk and share their experience and knowledge. I think this is nothing but a humble start, because I had a discussion with NDMA yesterday with one of the key officers there, and they were very happy that NIDM and FICCI have come together to within the span of 10 days to come up. And I shared a list of some speakers which have spoken and who will be talking today, and they were I would say ultra pleased with how could you gather all of them? They must be all busy with what has happened. And I said, but that was the idea. We need to get the word out that the government, the industries are equally concerned, and they are worried of what has happened. We are still in grief, but we need to look ahead and we need to prepare for the future. We need to be better equipped to deal with such things. As you also mentioned, Dr. Ghosh, yesterday and even day before, that it was the February time when this happened. It was the time when the water flows and everything, the amount of water which gets packed there, accumulated there, was not as much as it would be in the summers. So it came as a warning signal for us as well, that moving forward we can't take landslides or avalanche or GLOF in isolation. What Dr. Surya Prakash also mentioned, that it has to be a multi-hazard approach which we need to adopt as a country, as an ecosystem which includes all important stakeholders. And I think I must congratulate you first of all for I think if I was in the government, I would only pick up my phone and call you for any solution regarding this, because you have your hands spread and hands jointly associated with such great minds in the industry, especially from the academia, people who are really not only academia but from research institutions also, from technology point of view also, from people from civil societies. I think all of these people are important stakeholders, and I think we've brought them all together. We've had over 250, 300 participants almost on all days, and I can't just I would like to acknowledge a few of the names who've really been there, and they've been sending us compliments of this, like Sameer Jamatia, you mentioned earlier, Karamveer, Lagan Sahni, Akash Pawar, Devender Khokhar, Mohammad Fayaz Ansari, Saddam Hussain, and all of these, Professor Manavalan, and they've been all Veluru Ramesh, Damodar Panda. I think they've had some questions also, but I think most of the questions, very interestingly, this is one of the first very unique instances when whatever questions were there before the OTP started in the minds of people who had come as participants, you could get some, very organic answers to them in the presentations, and no presentation was an overlap. The same subject had different takes and people from different walks of life, from different backgrounds, talking on this subject from their own perspective, and gave a different light every time we heard them. I think it was a very, very well organized, I would say, well collated set of speakers. And thank you so much, Dr. Ghosh, for all your great understanding of the subject. And I think that has made this possible. And I can't help thank you enough, you and all your colleagues who've been part of this entire journey of 3 days, and then whatever effort went behind this, organizing this. And I think this is, as I said, is a humble beginning, and we must continue. And this should be our endeavor, that we continue walking this path of getting, even, sure, people who've come as experts, they have enjoyed our company also. If we call them again, they would definitely want to come and contribute, because we need to reach out. Our outreach has to be more aggressive. We need to reach out, maybe at a state level. Someone mentioned yesterday, maybe at a state level we have such good relations and contacts in Himachal, Jammu Kashmir. Dr. Ahmed was there earlier today. Uttarakhand, Murugesan ji, who's the Secretary in charge of disaster management. I would be going and seeing him next week. We recently, have built such very good contacts in the past 4 or 5 years with NEC, Northeastern Council, and the Ministry of Donors, Sikkim and Assam and Arunachal, and even Meghalaya. We've been working with them from a state point of view also, and at an NEC level also. I think we can really now target penetrating within the states and penetrating across to the right and the relevant stakeholder in those states who are at the policy level, who are at the decision-making level. And I am sure with the power which NIDM brings and the connections, industrial connections which FICCI brings to the table, this both together is a very strong force, to make that impact which we are, sort of assigning us to do. So over to you, Dr. Ghosh. Any comments you would like to make?
Yeah, you have nicely. Of course, it is not that you or everyone. I'm not there. It is all because of you all and all experts, at least through this platform. Country or entire world has got a feeling that what treasure or minds that we have, the minds of mind that across that, especially young minds that who are working in their own field. Yeah. So this electrifying or igniting platform that we try to create over there, and which will be there online also, with our 200 plus participants, that which I can see, that at least once Einstein said that we don't have to know, or we don't have to have all kinds of knowledge. At least in times of problems or necessity, we must know that what kind of things are to be procured or collated, so that we can solve the problem. So here at this inopportune moment for the country, for the humanity, but opportunity that created, even COVID, and the opportunity that we have created through your bike. And so at least our participants and entire country, they have come to know that not what I am or what FICCI is, but at least who is who among us in the country who are working in different fields and then how they can contribute. They have got the potential. We have to tap their potential for the country's benefit in Make in India spirit. This is what I want to say. And on behalf of NIDM, our ED NIDM, I would thank that all the participants first, and also all the colleagues who are working in their area, that who have shared their time, and also excellently they have defined what actually science is, what technology is, what is investigation is, all together. They have made a exploding contribution that shedding light on the problem that we have faced, and the problem that in a way that we can solve it. Now it is up to us, all of us, and community, even state government, that what you mentioned, even in the northeast area, wherever, we would like to see that to make it more categorical, presentation, and as well as taking up the problem and solving the things on the site itself, solving the problem at the site itself, bringing them together in the plan. So only thing is that now with the help of technology and know-how, with the kind of wonderful communication that we enjoy these days, smart communication, that it is just hardly 2 or 3 days of hard work that we all tried, Vicky and all, we have tried, and everybody came forward. So I would say that it is more salute due to our experts and also the participants that who have been passionate enough to be with us and to make us going, even today being even Saturday. Thank you.
Thank you so much, Dr. Ghosh. I think you really summed up really well. And I think we other than compliments and best wishes we are getting from our participants, they're also suggesting us some new area where they would expect us to throw more light during our upcoming OTPs. And one of this is the community preparedness for disaster, which is a very, very important aspect, and we acknowledge and appreciate that. And thank you so much, Dr. Deepak Vishwakarma, for that suggestion. In fact, under a partnership of FICCI and IDM, we've had a series of webinars. One of the webinars was dedicated to community preparedness, and we touched aspects which usually get ignored, was the mental health aspect. And we had experts from NIMHAMS in Bangalore, which is now the Apex Institute for disaster risk management related issues. It's a center of excellence which they have an understanding with us, and we assure you we'll do more training programs and more such workshops and e-conclaves and maybe physical conclaves in times to come with them. The very famous IBAS in Chadra, Delhi, which is the Institute of Human Behavior and Allied Sciences. They are also associated with our platform, and we will soon prepare a program which is dedicated on community preparedness and which also looks into the mental health aspect of communities. So that's a good suggestion. There is obviously sorry?
Both Ajanta and Sanjay Rana, if we may request them to say a few words other than slides, other than their presentation.
Yeah, of course. Of course. Yes, but both, Ajanta, Dr. Goswami, his presentation has been really admired by the audience, and people have really had a good time. I think the entire day Dr. Rana's presentation was, just brilliant. In fact, Dr. Surya Prakash address and he touching upon aspects of multi-hazards was very well received by everyone, and we thank all the speakers today for taking out time and sharing their knowledge with us. In fact, Samir, as I was saying, Samir Javatia, he says, please you can organize on bamboo as materials for construction.
It is already decided. I have conveyed him through Tripura Disaster Management Authority.
Yeah.
Doing a webinar on that. We have fixed a time.
Yeah. So I think all of that. Rana, I would just like to have you for your final comments. What do you get of such initiatives between government and private sector, and how do you think we can improve upon on this?
Well, thank you very much. As I particularly feel is that whenever we are facing a crisis, we face a crisis as a humanity, and we have to face the crisis as a humanity. All right. First of all the boundaries have to be erased. Right. Thankfully, I am in a space that I'm a chairman of Aqua Foundation, which is a non-profit organization. I run a company. And I have a very good experience of working in the government sector through my atomic energy, and today also most of my friends are in government sector. First of all these boundaries have to be erased. Yeah. The personal egos we carry with ourselves have to go somewhere. Okay. I try to learn even from the interns who come to my office to do their internship, because they bring new and fresh knowledge. All right. So we as professionals can never sit with our egos that we know everything. Technology is changing at a very rapid pace, and these kind of platforms should be made available for exchange of ideas. All right. Not only for people to come and speak, like for example, I am guilty of that. I joined the session only today at 2:30. All right. Now, having gone through this session, ideally I could have actually joined it 2 days back and gone through all the presentations, which I'm sure will be made available as a video or something like this. But these platforms can be made more interactive so that people can exchange ideas. COVID has given us this great opportunity.
Absolutely.
That online medium has been accepted now. Earlier, for everything, even if it was Dr. Ghosh, he would have called me and said, can you come for a meeting? All right. Or anyone was there. It was always, can we meet sometime for a cup of coffee or tea and discuss it? And it used to take months before you could actually meet. And these kind of experts coming together on a single platform, it would have taken 3 to 4 months to put them together. So this is an opportunity which has come to us. We as a humanity should address to all these challenges together, keeping our egos and our positions on one side and focusing only on solutions. And I think it's a great initiative which you have taken. I'm very happy to be part of it, and I look forward to continuing my participation in any possible way I can. Thank you very much.
That's very heartening. Thank you so much, Dr. Rana, for your recognizing us as a good platform, because we know this is and taking a leap from where you also mentioned that how COVID has eventually become an opportunity, and I think we are a true example of that. I think we never worked with so many partners in a span of 9 months as we have during this COVID times. And I think this partnership of FICCI and IDM, although we've been partners for years together, but I think the sort of impact we've been able to create, or we've been able to make from a capacity building perspective, I think that is beyond any measurable scale, because if there were measurable scales, there were scales pre-COVID. I think we have to redefine them, because the impact has been such, and we are so glad we've always been in touch with these experts, and in forums. And you said, if there was a meeting, you would have been called. You could be available, you could not be available, but sitting at the comfort of your home and offices, and dedicating time, maybe you've dedicated 3 hours, more than 3 hours to us. And I think it's a knowledge exchange platform, and this is what was required. And I think this is here to stay. So this virtual world is here to stay, and it's going nowhere. COVID would be over soon. Some say we are in the middle of it, some say we are at the fag end of it. But I think whatever having said and done, I think we would continue this relationship, this forum, this medium. And we can't replace physical meetings, but I think in future we can't even replace virtual meetings and such deliberations. Very rightly said. Thank you. Ajanta, are you there? Can we have you, Dr. Goswami? Ajanta Goswami, if we could have you. I think he might have slipped out or something. But I think on that note, Dr. Ghosh, on behalf of FICCI, on behalf of my Presidium, on behalf of my Secretary General, I thank Major M.K. Bindal, ED NIDM, I thank you wholeheartedly, Dr. Chandan Ghosh, the team behind you, which has been working relentlessly for so many years together. Your experience, in this area of resilient infrastructure, I think is coming in very handy to our country, and I'm sure other countries as well. On behalf of the DR and the Disaster Risk Management team at FICCI, the CIDM Board Chairman, Dr. General J.R. Bhardwaj, Lieutenant General Dr. J.R. Bhardwaj, who was there at the inaugural, Dr. Muzaffar Ahmed, Mr. Man Singh, Mr. Rao, and all of us, we would like to thank you. I join my colleague Akhil Gupta, Mainak Majumdar, Varun Sharma, in thanking you wholeheartedly for this opportunity, and we look forward to continuing this relationship into more such meaningful initiatives, online training programs, or workshops, or I would say e-conclaves on this subject and more subjects of national importance and national relevance. So I would like you to please present the vote of thanks, concluding remarks. It would be an honor to have you.
I think we have just as a matter of note on behalf of NIDM, we are thankful first to all the participants who were there. I can see about 200, and then all of the learned speakers who put their time, effort, as well as their solidarity and integrity to help the country with their knowledge and know-how, and the way that they have responded, and also the discussions, questions, and cross questions and deliberations that we had over these 3 days. By your moderation as well as your team behind, of course, under the overall leadership as well as mentorship of Dr. General J.R. Bhardwaj, who always there in our this inspiration. And also, I would say that we are going to make a report on this, which we'll be sharing to each of the speakers to on that, whatever we'll be noting, and they can update it, they can make it more specific, and so that we can share it. As Dr. Muzaffar Ahmed, our NDMA member, mentioned in the beginning of this today, that we would like to make this report, like the previous one also, the report that which will be given to the concerned officials, government channels, and online, even through an IDM portal and your portal everywhere. And these presentations are there online, so that the entire humanity get a source of inspiration from these deliveries that made by our speaker and kind of interaction that we had. It is all for the cause, because we are living for a cause. So we thank you all and giving us, rather you, FICCI and NIDM, making such kind of gathering over online. And in fact, in near future, maybe next month, we are going to have, we may mention that on urban flood or riverine flood related things, that we are going to have a e-conclave level, and where we would like to see that there may be some parallel session will go on, expert to expert, like it will be like here, he confessed rather, because people are so busy that we also see that not only you, me, we are attending all the courses, but we would like to make a one-to-one or one-to-two kind of connected people where parallel session will go on. And so in that case, say a person dealing with flood, in Japan or flood dealing in China can have a one-to-one correspondence and interaction parallelly on a definitive slot where our participants can join there and they can switch over. Actually, what happened really in a real conference where virtual also we can make them in a selected group where they can switch over to flood session or flood infrastructure or early warning like that. So that kind of things also we can create. I think our next aim will be to have that kind of one-to-one, one-to-many specific interaction where which you have been doing. We have been doing these things, but we would like to see that we can arrange in our next e-conclave. Conclave, the real meaning is to have, the people of like-minded people will share and exchange information, and then they get equally benefited. So with this note, I thank you again, and also PK member and CIDN member coming with such a wholeheartedly taking this initiative to such a great height.
Thank you. Thank you, Dr. Ghosh. Thank you for your very encouraging comments. And you've always been behind the success of all initiatives we do with you. And it's even if it was a physical CIDM conference anywhere in the country, we've always had Sikkim, Gujarat, anywhere we do, you're always there for us. You take out time. You not only take out time to be there, but you also help us connect with the right minds and with the right industries also. And we are very, very thankful for all your support and guidance all these years. And ladies and gentlemen, who the participants till 200 in number, I would just like to tell you, I would not take much of your time on a Saturday. It's a weekend, and we wish you the best of your weekend. We will be issuing the certificates for this particular OTP along with the presentations. We'll collect all the presentations of these experts who've made themselves available from 18th till today. All the presentations will be compiled, collated, and sent you across along with your certificate. Give us at least 3 weeks of time, because it takes time for us to get all of this together. And I'm sure most of you must have attended our previous programs. We've been able to issue almost all the certificates, and we are clear as of now. But please give us time, for at least 3 weeks time to reach out to you with the certificates for this particular OTP and the presentations. And we have already announced our next OTP in partnership with NIDM on industrial safety with focus on oil and gas sector. And we will write to you separately on that. And we look forward to your participation, active participation, like for this OTP in upcoming events as well. The idea is to build better capacities in the country. Capacity development, capacity building and training is our motto, and this is what we want to push as much as we can under this partnership of NIDM and FICCI. We have been mandated by the government to do this, and I hope we are doing justice to that mandate, and we will continue working in that direction of bringing the best of the minds, the best of the experts, the best of the stakeholders on our platform, no matter what it takes. But we will give you the maximum value for your time every second you spend on our platform. So on that note, Dr. Ghosh, should we?
Is there any system here where participant side they can also speak out? Is there any other than chat box?
Yeah, there is. Perhaps for that they will have to, they have to come up on the chat box and ask us if they have a question. Just tell us if they want to speak. We can add them into the panelist list to speak up.
Okay.
But I think most of them have started leaving now. So maybe from next time we can have that sort of arrangement. And maybe like Devendra Khokhar, he's complimenting us for a great session, and so is Ranjan Kumar Das. We have Mohammad Ansari ji, Mustaf Saha, Dr. Mani Prakash Aravali, I think all of them, there are so many, Akash Pawar, Lagan Sahani.
Yeah.
I mean, I think it's just flooded with the comments, their best regards and wishes. Ranjan Kumar Das, I mentioned, Satya Prakash, Sham Narayan Bharti, Ajanta Goswami, Rigala Manohar, Keshav Tadia, all of them. I think thank you so much to all the participants who've really dedicated a major chunk of the last 3 days to this OTP. I'm sure and I'm hopeful. So I'm hopeful and sure that both at the same time that you've like myself, you all have, whoever is attendees has become more wiser than what we were on the morning of 18th February. So on that note, I think we can say bye-bye to everyone. Thank you so much for your time, effort, and thank you again, Dr. Chandan Ghosh, and special thanks to my colleagues, Akhil, Menak, and Varun, for without which this would not have been possible at all. So thank you guys. A great job done. I think we can now move on and await the next OTP, which will be next week. On the 24th, we start. Yes.
Yeah.
Thank you so much. Okay, sir. Bye-bye. Have a good evening ahead. Enjoy your weekend. Bye-bye. Take care.